There's something massive lurking in the universe, something we were never supposed to see. For centuries, astronomers have mapped the stars, believing we had a clear picture of the cosmos. But what if I told you that right in our own backyard, behind thick clouds of cosmic dust, entire galaxies have been hiding in plain sight? These aren't tiny, insignificant clusters of stars. Some of them rival the Milky Way in size and could hold secrets that rewrite everything we thought we knew about space. Why have they remained hidden for so long? What might be lurking in their depths? And if we've been blind to entire galaxies, what else could we be missing? But before we continue, subscribe to the channel so you don't miss out on any of these videos. For decades, astronomers suspected that something was lurking behind this thick veil, but they had no way to see through it. Optical telescopes, the same kind we use to gaze at distant stars and planets, were completely useless in this situation. The dust of the Milky Way acts like a cosmic smokescreen, absorbing and scattering visible light, making everything behind it impossible to see. And so, for generations, an entire section of the universe remained in total darkness. But as technology advanced and astronomers started using different methods, like radio waves and infrared imaging, what they discovered was beyond anything they expected. Hidden beyond the Milky Way's dust were not just small celestial objects or faint clusters of stars, but entire galaxies, massive, sprawling galaxies that had remained undetected. Some of them are so large that they rival the Milky Way itself. Others are part of structures so enormous they challenge our understanding of cosmic formations. The idea that billions of stars, countless planets, and perhaps even unknown forms of life were concealed right in our cosmic backyard is both thrilling and unsettling. This discovery has completely changed how we see our place in the universe. It has revealed just how limited our perspective was, even with all of our advancements in astronomy. And more importantly, it raises the question, what else is out there, hidden in ways we haven't yet figured out how to uncover? If entire galaxies can remain unseen for so long, what other cosmic mysteries are still waiting to be discovered? To understand how these hidden galaxies remained unnoticed for so long, we have to talk about the structure of our own galaxy. The Milky Way is a barred spiral galaxy, with massive arms of stars, gas, and dust spiraling out from a central core. While this structure is breathtakingly beautiful, it's also a major problem for astronomers trying to observe beyond it. The galactic plane, the dense, dusty region along the disk of the Milky Way, blocks our view of about 20% of the sky. This blocked region is called the zone of avoidance, and for most of human history, it was exactly that, an area of space we simply couldn't see. But why is this dust such a big deal? Dust in space isn't like the dust you find on a shelf. It's made of tiny particles of carbon, silicon, and other elements, often created by dying stars. These particles absorb and scatter visible light, making the region incredibly opaque. To an optical telescope, this part of the sky looks like an endless dark void. But astronomers didn't stop at visible light. By using radio telescopes and infrared observatories, they were able to penetrate the dust and finally see what was hiding behind it. One of the most groundbreaking discoveries in this hidden region was a massive galaxy known as Milky Way. This elliptical galaxy is about 10 million light-years away and is one of the closest giant galaxies to the Milky Way. Yet, for most of human history, we had no idea it existed. It was only in the late 1960s that Italian astronomer Paolo Maffei used infrared observations to detect it. Even then, it took decades for astronomers to fully understand its size and significance. Milky Way is just the beginning. Beyond it, more galaxies have been uncovered, including Milky 2, IC 342, and countless others that were completely invisible before infrared and radio technology came into play. Some of these galaxies are part of massive cosmic structures, like the Perseus Pisces supercluster, a vast chain of galaxies stretching across hundreds of millions of light-years. The fact that such immense structures were hidden behind our own galaxy's dust shows just how much we still don't know about the universe. But perhaps the most shocking discovery came in 2016, when astronomers uncovered a previously unknown galaxy cluster, named the Vela supercluster. This colossal structure, located roughly 800 million light-years away, contains thousands of galaxies and could have a significant gravitational influence on the motion of our own Milky Way. The idea that such a massive force in the universe was hidden from us simply because of the dust in our galaxy is mind-blowing. It makes us wonder, what else is out there, waiting to be discovered? As telescopes become more advanced, we are starting to see even deeper into these hidden regions. The James Webb Space Telescope, with its powerful infrared capabilities, is expected to reveal even more of these lost galaxies, helping us piece together the true structure of the universe. And with upcoming radio telescope projects like the Square Kilometre Array, our ability to detect hidden cosmic objects will only improve. But beyond the science, the discovery of these hidden galaxies is a reminder of something profound. It shows us how much of the universe is still unknown, how much is waiting just beyond our reach. For every mystery we solve, 1,000 more questions emerge. And if entire galaxies, each potentially filled with billions of stars and countless planets, could remain hidden for so long, who's to say what else is out there? This is just the beginning. With every new discovery, we are not just learning about the universe, we are redefining our place in it. We once thought Earth was the center of everything. Then we learned it was just one planet among many. Then we realized our sun was one of billions of stars in a galaxy. Now we are seeing that even our galaxy is just one among countless others, some of which have been hiding in plain sight. And the most exciting part? We are only scratching the surface. The fact that we are only now uncovering these hidden galaxies raises a huge question. How many more are still beyond our reach? If massive galaxies and even entire superclusters have remained undetected for so long, it's entirely possible that even larger structures exist, just waiting for us to develop the right tools to see them. But before we get into what might still be out there, we need to break down exactly how astronomers managed to pull back the cosmic curtain and reveal what was hidden beyond the Milky Way's dust. Infrared telescopes played a huge role in these discoveries. Unlike visible light, which is blocked by interstellar dust, infrared light can pass through it, giving us a clearer view of what's beyond. The Spitzer Space Telescope, for example, was one of the most important tools in detecting hidden galaxies. By scanning the sky in infrared wavelengths, it revealed structures that were completely invisible to optical telescopes. And then came even more advanced telescopes, like the James Webb Space Telescope, which has taken infrared imaging to a whole new level, allowing us to see deeper and clearer than ever before. But infrared light isn't the only way to see through cosmic dust. Radio waves, which have much longer wavelengths than visible light, can also penetrate these dense clouds. This is where radio telescopes like the Parkes Observatory in Australia and the Arecibo Observatory in Puerto Rico, before its collapse, became invaluable. Using radio waves, astronomers have been able to detect the hydrogen gas in these hidden galaxies, mapping their structures and revealing just how massive they truly are. And then there's X-ray and gamma-ray astronomy. While these high-energy forms of light don't show the structure of galaxies as clearly as infrared or radio waves, they do reveal energetic processes happening within them, like the presence of supermassive black holes, intense star formation, and other extreme cosmic events. The Chandra X-ray Observatory, for example, has detected powerful emissions from hidden galaxies, confirming their existence and giving us clues about the kinds of activity taking place within them. One of the most exciting aspects of these discoveries is that they don't just change our understanding of what's out there. They also change our understanding of how galaxies evolve. Many of the hidden galaxies we've found appear to be much older than the Milky Way, meaning they formed in the very early universe. Some of them show signs of past collisions and mergers, events that shaped their structures over billions of years. This suggests that the hidden universe is not just a collection of unnoticed objects, it's a key piece of the puzzle in understanding cosmic history. And let's talk about scale for a moment. The galaxies we're discovering in this hidden region aren't just small, obscure collections of stars. Some of them are absolutely enormous. MAF-A1, for instance, is a giant elliptical galaxy that is several times larger than the Milky Way. IC342 is a sprawling spiral galaxy that, if it weren't obscured by dust, would be one of the brightest galaxies in our sky. These are not minor cosmic players. They are massive structures that have been influencing the universe's gravitational balance without us even knowing. Perhaps even more intriguing is the idea that some of these hidden galaxies might harbor conditions suitable for life. If we assume that life could exist in other galaxies just as it does in our own, then the discovery of these hidden galaxies means there could be countless new worlds out there, worlds that we've never even considered in the search for extraterrestrial life. Could there be civilizations in these galaxies that have been hidden from us all this time? It's a mind-blowing thought. And then there's the idea of dark matter. Hidden galaxies provide a unique opportunity to study this mysterious substance, which is thought to make up most of the universe's mass. By observing the way these galaxies interact with each other, and with the Milky Way, astronomers can gather new data on how dark matter behaves. Some of the hidden galaxies appear to be rich in dark matter, while others challenge our understanding of its distribution. Every new discovery adds another piece to the puzzle, and we are still far from having all the answers. But this is where things get even crazier. Because if entire galaxies can remain hidden from us for so long, what about something even bigger? What if there are entire clusters, superclusters, or even unknown cosmic structures that are still beyond our reach? The discovery of the Vela supercluster in 2016 was proof that such things can exist. Before it was found, astronomers had no idea such a massive structure was there. Now, some scientists believe that even larger structures could be lurking behind the Milky Way's dust, waiting to be uncovered. It's not just about what we've found, it's about what we haven't found yet. And that's what makes this mystery so exciting. The more we discover, the more we realize how much we don't know. Every time a new telescope comes online, we push our boundaries a little further. And with upcoming projects like the Vera C. Rubin Observatory and the Square Kilometre Array, we are poised to make even more groundbreaking discoveries in the near future. But beyond the scientific implications, there's something deeply humbling about all of this. It reminds us that we are just tiny observers in an unimaginably vast cosmos. That for all of our advancements, for all of our technology, we are still barely scratching the surface of the universe's secrets. The night sky we look up at is just a fraction of what's really there. And perhaps, even after all the hidden galaxies we've found so far, the greatest discoveries are still waiting to be made. If hidden galaxies have remained unseen for so long, what else could be out there, just beyond our reach? The possibility of even larger structures, cosmic anomalies, or entirely new forms of matter lurking in the shadows of our cosmic neighborhood is staggering. Every new discovery pushes the boundaries of what we thought was possible, and with each step forward, the universe reveals itself to be far more complex and mysterious than we ever imagined. The idea that entire superclusters have remained undetected raises serious questions about the accuracy of our current cosmic maps. If the Milky Way's dust can obscure something as massive as the Vela supercluster, then there's no telling what other massive formations might still be hidden. Some astronomers speculate that these unknown structures could even be influencing the movement of our galaxy in ways we don't yet understand. The phenomenon known as the Great Attractor, for instance, suggests that a gravitational force beyond our view is pulling galaxies toward it. Could hidden galaxies or even entire undiscovered superclusters be part of this mysterious force? But let's take this a step further. If entire galaxies can be hidden, what about rogue planets, wandering stars, or even black holes? We already know that interstellar objects can drift through the Milky Way, largely undetected until they pass close enough for us to notice them. But what if a significant number of these objects exist in the hidden regions beyond the Milky Way's dust? Could there be entire planetary systems that have never been seen, potentially harboring life? And then there's dark matter, the invisible substance that makes up most of the universe's mass. The discovery of hidden galaxies gives astronomers a new way to study dark matter because these galaxies interact with it in ways we don't yet fully understand. Some of the hidden galaxies appear to contain far more dark matter than expected, while others seem to challenge existing models of dark matter distribution. If we can study these galaxies more closely, we may be able to unlock some of the biggest mysteries in physics, including what dark matter actually is. The technology we have today is making these discoveries possible, but the future holds even greater potential. The James Webb Space Telescope has already begun revealing parts of the universe we could never see before, and upcoming observatories like the Vera C. Rubin Observatory and the Square Kilometre Array will take our ability to peer into the hidden universe even further. These new tools will allow us to map these obscured regions in unprecedented detail, potentially revealing even more galaxies, superclusters, and cosmic anomalies. But what if some things are meant to stay hidden? Could there be parts of the universe that are fundamentally beyond our ability to detect? Some scientists speculate that there could be regions of space that are permanently hidden from us due to the expansion of the universe. As space continues to stretch at an accelerating rate, more and more galaxies are slipping beyond our observable horizon, meaning there are already cosmic structures we will never be able to see, no matter how advanced our technology becomes. This realization is both thrilling and unsettling. It suggests that the universe is even larger and more complex than we can comprehend. And it raises one final, chilling question: if there are entire galaxies we've only just begun to see, what else has been hiding in the darkness? The idea that entire galaxies, superclusters, and cosmic structures have remained hidden for so long is mind-blowing. It completely changes our understanding of what we think we know about the universe. The more we uncover, the more we realize just how little we've actually seen. If the Milky Way's dust can obscure something as massive as the Vela supercluster or entire galaxies like MAF-A1 and IC342, then what else is out there, lurking just beyond our view? The scale of what remains unseen could be beyond our wildest imagination. We already know that dark matter makes up most of the universe's mass, yet we can't directly observe it. What if the same is true for other unseen structures? Could there be entire galactic civilizations, vast cosmic formations, or even unknown forms of matter that have remained hidden, simply because our current technology isn't advanced enough to detect them? The thought alone is enough to completely reshape how we think about the universe and our place in it. One of the most baffling aspects of hidden galaxies is how they interact with known cosmic structures. We've observed gravitational effects that suggest something massive is pulling on galaxies, yet until recently, we had no idea what was causing it. The Great Attractor, a mysterious region of space pulling galaxies, including our own Milky Way, toward it, is one of the most perplexing cosmic phenomena. Astronomers have theorized that this immense gravitational force is due to a supercluster of galaxies, but for decades, it remained unseen, shrouded by the thick dust and gas of the Milky Way. Only in recent years have infrared and radio telescopes begun to reveal the galaxies hidden behind this veil, confirming that there is indeed something massive lurking in that region. But here's the real mystery: is the Great Attractor just one of many hidden forces influencing the structure of the universe? If there are entire superclusters that have remained undetected until now, could there be even greater gravitational anomalies pulling at our galaxy from even deeper in the unseen cosmos? It's not just the sheer number of hidden galaxies that's astonishing, it's their size and composition. Some of the galaxies found in these obscured regions are enormous, far larger than the Milky Way. Elliptical giants like MAF-A1 are several times the size of our own galaxy, containing hundreds of billions of stars. The fact that such massive structures were hiding right next to us in cosmic terms is a wake-up call. What's more, some of these hidden galaxies appear to be incredibly ancient. When we peer into them with infrared telescopes, we're looking billions of years into the past, observing galaxies as they were when the universe was still young. Some of these galaxies have undergone major collisions and mergers, shaping their structure over billions of years. This tells us that the hidden universe isn't just a collection of unnoticed objects, it's a fundamental part of cosmic history that we've been blind to until now. And then there's the question of what's actually inside these galaxies. Are they just clusters of stars and gas, or could they contain something even more unexpected? If we assume that life could exist in other galaxies just as it does in our own, then the discovery of these hidden galaxies means there could be countless new worlds out there. Worlds we never even considered in the search for extraterrestrial life. Imagine an entire civilization existing in one of these obscured galaxies, completely undetected by us, just as we have been unaware of them. If they have the capability to observe the cosmos, do they know about us? Or are they, too, just beginning to uncover the hidden nature of the universe, just as we are? The idea of undiscovered life existing in these galaxies adds an entirely new layer of mystery. The implications of these discoveries go far beyond astronomy. They challenge fundamental aspects of physics. One of the most perplexing issues is the role of dark matter in these hidden regions. We know that dark matter is responsible for holding galaxies together, preventing them from flying apart as they rotate. But in some of the newly discovered galaxies, the distribution of dark matter appears to be different from what we expected. Some of these galaxies seem to be incredibly rich in dark matter, while others contain far less than we predicted. If these findings hold up under further study, they could force us to completely rethink our understanding of dark matter and how it interacts with normal matter in different environments. Could there be unknown variations of dark matter in these hidden galaxies? Could the Milky Way's dust have been obscuring clues about the true nature of the universe's most mysterious substance? And what about black holes? We already know that supermassive black holes sit at the centers of most galaxies, but if entire galaxies have remained hidden, then we may have been missing some of the largest black holes in existence. Some of these newly discovered galaxies show strong X-ray and radio emissions, suggesting the presence of massive black holes actively feeding on surrounding matter. If these black holes are as powerful as they seem, they could be influencing the movement of entire galaxies, warping spacetime in ways we have yet to fully understand. It raises the question, could some of the unexplained gravitational anomalies we've observed in the universe be caused by hidden supermassive black holes in these galaxies? If so, then our current understanding of how galaxies evolve and interact with one another could be missing a crucial piece of the puzzle. The more we uncover, the more questions arise. If so many galaxies have remained hidden for so long, how do we know we've found them all? The truth is, we don't. We are still only scratching the surface of what infrared, radio, and X-ray telescopes can reveal. As technology advances, we may find even more galaxies, superclusters, and cosmic structures that we never suspected existed. The upcoming Vera C. Rubin Observatory, for example, will conduct an extensive survey of the sky, mapping millions of previously unseen celestial objects. Meanwhile, the Square Kilometre Array will give us an unprecedented look into radio wave emissions across the universe, potentially revealing even more hidden galaxies. And then there's the possibility of entirely new methods of observation. Exotic techniques like gravitational wave astronomy or neutrino detection could open doors to even more discoveries lurking in the shadows of the cosmos. But perhaps the most unsettling thought is this: what if some things are truly beyond our reach? The universe is expanding, and as it does, more and more galaxies are slipping beyond the cosmic horizon. This means that some structures, no matter how advanced our technology becomes, will never be visible to us. They are moving away from us faster than the speed of light due to the expansion of space itself, placing them forever out of reach. This realization is both awe-inspiring and humbling. It suggests that, no matter how much we learn, there will always be aspects of the universe that remain a mystery. And that leads us to the ultimate question: what else is hiding out there? We have uncovered hidden galaxies, superclusters, and gravitational anomalies, but what if those are just the beginning? What if the Milky Way's dust has been hiding something even greater, something that would completely change our understanding of reality? Could there be unknown cosmic structures that defy everything we think we know about physics? Could there be forms of matter or energy that have remained unseen for all of human history? Every time we peel back another layer of the cosmic veil, we find more than we expected. And if history has taught us anything, it's that the greatest discoveries are always the ones we never saw coming. The realization that so much of the universe has remained hidden from us isn't just a question of what we haven't seen, it's a question of how much we can see. Our instruments are limited by the physics of light itself. Most of our telescopes rely on electromagnetic radiation, but that's only one way to observe the cosmos. What if there are forms of radiation, or even entirely different forces, that carry information about the universe in ways we haven't yet discovered? We already use gravitational waves to detect cosmic events like black hole mergers, but what if some hidden galaxies are only detectable through yet unknown physical interactions? What if we're missing entire categories of celestial structures simply because we've been looking with the wrong tools? There's another unsettling idea. What if some hidden galaxies are actually deliberately hidden? The concept might sound like science fiction, but it's a serious question in the search for extraterrestrial intelligence. Some scientists have speculated that advanced civilizations could use cloaking technology, either by manipulating light around their planets or by minimizing their thermal signatures, to remain undetected. If that's the case, then some of the galaxies we've recently discovered might not just be obscured by cosmic dust. They might be home to civilizations that have chosen to stay invisible. Could there be entire galactic societies that have perfected the ability to hide from prying eyes? Could there be signals hidden in the cosmic noise that we haven't yet learned how to decipher? Even if we assume that these hidden galaxies are purely natural and not the result of advanced technology, their discovery has profound implications for the structure of the universe. One of the biggest mysteries in cosmology is why the large-scale arrangement of galaxies follows patterns that resemble a cosmic web, vast filaments of matter connecting galactic clusters, separated by enormous voids. The presence of hidden galaxies suggests that our current maps of this cosmic web are incomplete. If we're only now uncovering some of the largest structures in our cosmic neighborhood, what does that say about the rest of the universe? Could there be even larger voids and filaments that we have yet to detect? Could there be entire types of galaxies that exist in hidden regions of space, forming a new classification of celestial objects? Then there's the question of time. When we look at galaxies, we're seeing them as they were millions or even billions of years ago. Some of the hidden galaxies we've only recently uncovered might not even exist anymore. They could have merged, collapsed, or changed beyond recognition. The fact that we are just now seeing them means that we are effectively looking at the past, peering into a version of the universe that no longer exists. What if, in some cases, our observations of hidden galaxies are actually showing us the remnants of ancient cosmic civilizations, long extinct? What if some of these galaxies once harbored life, only to be wiped out by unknown cosmic events? Could we be witnessing the shadows of dead civilizations, echoes of life that existed billions of years before us? The more we think about the implications of these hidden galaxies, the more mind-bending the possibilities become. If entire superclusters have been hiding behind the Milky Way's dust, then what about other regions of space? What about the Andromeda Galaxy, our nearest galactic neighbor? Could there be obscured structures lurking in its outskirts, hidden by interstellar clouds? What about the countless dwarf galaxies that orbit the Milky Way? Are we sure we've found them all? Could there be hidden companions to our own galaxy that have yet to be detected? Every new discovery seems to suggest that our picture of the universe is incomplete, and if history is any indication, the biggest revelations are still ahead of us. But perhaps the most fascinating aspect of all of this is how it challenges our perception of reality. For centuries, humans have believed that what we see is what exists. We thought the Earth was the center of the universe. We thought the Milky Way was all there was. Even after we realized that the universe was far larger than we ever imagined, we still assumed that our telescopes showed us the full picture. Now we know better. We know that vast portions of the universe remain unseen, hidden not by distance but by cosmic obstructions that our instruments are only now learning to bypass. And if this is true for galaxies, what else could it be true for? Could there be entire universes hidden beyond our reach? Could the structure of reality itself be layered in ways we haven't yet realized? If the cosmic web is far more intricate than we thought, could it be connected to something even greater, something beyond the boundaries of our observable universe? The discovery of hidden galaxies is not just an astronomical breakthrough, it's a fundamental shift in how we understand existence itself. If hidden galaxies are only now coming into view, what does that say about the limitations of human perception? For centuries, we have relied on light as our primary way of understanding the cosmos. But light is only one aspect of the universe's vast complexity. The more we explore space, the more we realize that what we don't see might be even more important than what we do. The discovery of galaxies obscured by the Milky Way's dust raises an uncomfortable but thrilling question. What if the vast majority of the universe is hidden from us in ways we don't even understand yet? Consider dark matter. We know it exists, not because we've seen it directly, but because of the gravitational effects it exerts on visible matter. Scientists estimate that dark matter makes up about 85% of the universe's total mass, yet we still don't know what it is. If entire galaxies can be hidden behind clouds of cosmic dust, then what about galaxies made primarily of dark matter? Could there be entire galactic structures composed of material that doesn't emit or interact with light in any way we currently recognize? If so, then our picture of the universe is even more incomplete than we realize. We might be living in a cosmos filled with invisible galaxies, their gravitational pull subtly shaping the universe while remaining completely undetectable to our current instruments. But hidden galaxies don't just challenge our understanding of what's out there, they challenge our understanding of how the universe evolves. The galaxies behind the Milky Way's dust are, in many ways, like fossils embedded in the structure of the cosmos. Because light takes time to travel, when we observe them, we are seeing them as they were millions or even billions of years ago. Some of them might be relics of a bygone cosmic era, their star formation processes frozen in time, their supermassive black holes long dormant. Others might be undergoing massive transformations at this very moment, but we won't see those changes for millions of years. This means that our entire view of the universe is built on a time delay. We are looking at history, not the present. This raises a mind-bending question. If hidden galaxies have only recently been revealed to us, what new discoveries are currently on their way? Right now, light from galaxies we have never seen before is traveling toward Earth. In a few decades or centuries, with even more advanced observational technology, we might uncover entire regions of space we never even knew existed. There could be massive cosmic structures, superclusters, vast voids, or even bizarre phenomena beyond our current understanding, hidden in plain sight, waiting for the right moment to be revealed. And what if some of these hidden galaxies contain planets teeming with life? The search for extraterrestrial life has primarily focused on exoplanets within our own galactic neighborhood. But if we are only now discovering galaxies that were previously obscured, then what are the chances that we've been missing inhabited worlds all along? If life exists in the universe, it might not be in the places we expected. It could be lurking in the depths of hidden galaxies, beyond the veils of dust and intergalactic obscuration, waiting for the day when our technology finally catches up to reality. Even more unsettling is the possibility that we are not alone in looking. If we are only now uncovering hidden galaxies, what if there are civilizations out there going through the same process? What if alien astronomers, using their own versions of telescopes, are just now discovering the Milky Way? What if they, too, have been peering through cosmic dust, trying to see beyond their own galactic limitations, only to find us hidden in their version of the zone of avoidance? The idea that intelligent life elsewhere in the universe might be just as blind as we are, struggling against the same cosmic obstructions, suggests that the search for extraterrestrial intelligence might be even harder than we thought. And yet, the more we uncover, the more we realize that we are part of something vastly larger than ourselves. The universe is not a static place. It is constantly shifting, evolving, revealing itself in layers. What we consider to be the known universe is just a fraction of what's really out there. Every hidden galaxy we find is another piece of the puzzle, another step toward understanding the true scale of reality. But for every answer we uncover, 10 more questions emerge. What else are we missing? What lies just beyond the reach of our current understanding? How many more hidden wonders are waiting in the darkness, just beyond the edge of our vision? The truth is, we are still standing at the very beginning of our cosmic journey. The hidden galaxies behind the Milky Way's dust are just the first revelations in a long series of discoveries that will continue to reshape our understanding of space. And if history has taught us anything, it's that the greatest mysteries of the universe are the ones we haven't even begun to imagine yet. The more we uncover hidden galaxies, the more we realize how much of the universe has remained out of reach, not just physically, but conceptually. We have long assumed that our maps of the cosmos, while incomplete, were at least accurate in their broad strokes. But every new discovery reminds us that reality is far more intricate than we ever imagined. The galaxies lurking behind the Milky Way's dust are more than just distant collections of stars. They are proof that our understanding of the universe is still in its infancy. And if that is true, then what other fundamental assumptions might be wrong? One of the most astonishing realizations is that the universe is not a simple, evenly distributed collection of galaxies. Instead, it is structured like a vast web, with immense clusters of galaxies connected by thin filaments of dark matter and separated by enormous voids. This cosmic web is the skeleton of the universe, dictating where matter collects and how galaxies evolve. But if we have only now uncovered entire galaxies hidden by our own Milky Way, then how can we be certain that our understanding of the cosmic web is accurate? Could it be that some of the largest-scale structures in the universe have been hiding from us, shaping the cosmos in ways we have yet to comprehend? The implications of this are staggering. The hidden galaxies suggest that the distribution of matter in the universe might not be what we assumed. If entire galactic clusters have been obscured, then the gravitational forces we have been measuring, the ones we thought were shaping the universe, may not be telling the whole story. Our calculations about the expansion of the universe, the nature of dark energy, and even the ultimate fate of the cosmos might need to be revised. If the universe is structured differently than we thought, then its long-term evolution might not be what we predicted. Could the so-called Big Rip, where the universe is torn apart by accelerating expansion, be an illusion caused by missing data? Could the balance of forces in the cosmos be different than we assumed, leading to a completely different ultimate outcome? Even more perplexing is the question of what lies beyond the regions we have now begun to uncover. The zone of avoidance, the region of the sky where the Milky Way's dust has obscured our view, has hidden countless galaxies from sight for centuries. But if we are just now discovering these structures, then what about the areas of the universe that remain even more difficult to observe? What about regions obscured not just by dust, but by gravitational lensing, extreme distances, or unknown cosmic phenomena? Could there be entire classes of galaxies we have never even imagined? This leads to one of the most unsettling possibilities. What if some regions of space are hidden not just by natural obstacles, but by the fundamental nature of the universe itself? Some physicists have proposed that there could be pocket universes, or hidden dimensions that exist beyond our current ability to detect. If entire galaxies can remain unseen behind something as simple as cosmic dust, then how much more could be concealed by barriers we don't even know how to measure? Could there be galaxies existing in a state of reality that interacts with our own only in subtle, almost imperceptible ways? Could some of the unexplained gravitational forces we observe be caused by matter that exists in another form of spacetime, one that overlaps with ours but remains invisible? There's also the possibility that some hidden galaxies are not hidden at all, at least, not in the traditional sense. Some astronomers have speculated that there could be ghost galaxies, collections of matter that do not interact with light in any detectable way. These galaxies would be made mostly of dark matter, with only a trace of normal matter, making them nearly impossible to see. If such galaxies exist, they could represent an entirely new category of cosmic structure, one that challenges our very definition of what a galaxy is. Could there be an entire unseen population of ghost galaxies scattered throughout the cosmos? And if so, how do they fit into our understanding of the universe's evolution? The idea of hidden galaxies also forces us to rethink one of the biggest mysteries in astronomy, the missing baryonic matter problem. Astronomers have long known that there is a discrepancy between the amount of ordinary matter we can detect and the amount that should exist based on our understanding of the early universe. If galaxies have been hiding behind cosmic dust, then how many more might be hiding elsewhere? Could the missing baryonic matter be locked away in galaxies we have simply failed to detect? Could some of it exist in a form that is even more difficult to uncover, perhaps a diffuse, invisible medium spread across the cosmic web? But beyond all of these technical questions, there is something deeply humbling about the discovery of hidden galaxies. For centuries, we have tried to place ourselves at the center of the universe, not physically, but intellectually. We have assumed that our instruments, our theories, and our understanding of physics have given us a clear view of reality. But the truth is, we are still fumbling in the dark. The universe is far more complex, far more mysterious, and far more surprising than we ever imagined. Every hidden galaxy we uncover is a reminder of how much we still have to learn. And if history has shown us anything, it's that the greatest discoveries are always the ones we never expected. If we've overlooked entire galaxies just because of the dust in our own Milky Way, what does that say about our ability to perceive the universe as a whole? How many more fundamental cosmic structures might still be hiding beyond the limits of our detection? This is not just a matter of expanding our galactic maps. It's about confronting the possibility that our understanding of reality is deeply incomplete. If galaxies can be hidden behind something as ordinary as interstellar dust, what else might be lurking in the shadows of the cosmos? Could there be entire superstructures, vast conglomerations of galaxies, concealed from us, shaping the gravitational balance of the universe in ways we've never realized? This raises an even more unsettling question. Have we miscalculated the forces that govern the cosmos? The gravitational pull of these hidden galaxies, though obscured from view, has still been at work for billions of years. If our models of cosmic motion did not account for them, then how accurate are our predictions about the large-scale evolution of the universe? Could some of the anomalies we observe, such as the unexplained movement of certain galaxies, be the result of massive, unseen structures exerting their influence from behind the veil of interstellar matter? If so, our entire framework for understanding cosmic expansion, dark matter distribution, and even the ultimate fate of the universe may need to be re-evaluated. It's also worth considering that the zone of avoidance might not be the only region of space concealing galactic mysteries. There are other cosmic blind spots, places where light from distant galaxies is warped, distorted, or absorbed before reaching us. Some regions of the universe are affected by gravitational lensing, where the immense gravity of an intervening object bends and magnifies light from objects behind it. While this phenomenon has allowed us to see distant galaxies we might otherwise miss, it has also introduced distortions and duplications in our cosmic maps. What if some hidden galaxies are lurking in areas where light has been stretched and twisted beyond recognition? Could there be entire civilizations existing in galaxies that appear as nothing more than faint smudges on our telescopes? And then, there's the matter of dark galaxies. These are hypothetical structures that contain little to no visible matter, making them nearly impossible to detect with conventional methods. Some astronomers believe that dark galaxies could be made almost entirely of dark matter, the mysterious, invisible substance that makes up most of the universe's mass. If such galaxies exist in large numbers, they could explain some of the gravitational effects we've observed but haven't been able to attribute to visible objects. Could it be that some of the hidden galaxies behind the Milky Way are not just obscured by dust, but are actually dark galaxies, structures that have always been invisible to us, regardless of our vantage point? The implications of these discoveries extend beyond astronomy and into the realm of fundamental physics. For decades, scientists have struggled to understand the true nature of dark matter and dark energy, two components that together make up 95% of the universe. If hidden galaxies contain unusually high concentrations of dark matter, they could provide crucial clues about what this mysterious substance actually is. Could it be that dark matter is not some exotic, undiscovered particle, but rather an entire class of unseen cosmic structures? Could our misunderstanding of dark matter be rooted in the fact that we've been missing half the picture? There's also the question of cosmic voids, massive, empty regions of space that seem to contain very few galaxies. These voids, which can stretch for hundreds of millions of light years, are some of the most puzzling features of the universe. But if entire galaxies have been hidden behind the Milky Way's dust, could it be that some of these voids are not truly empty, but simply obscured by cosmic dust, gravitational distortions, or other unknown factors? Could it be that our universe is not as lumpy and uneven as it seems, but instead more balanced and structured, with hidden galaxies filling in the gaps we thought were barren? All of this leads to an even more mind-bending possibility. What if the reason we can't see certain parts of the universe is not because of dust, or dark matter, or gravitational distortions, but because of the nature of space-time itself? Some physicists have speculated that the universe may contain hidden dimensions, or even parallel realities that exist alongside our own. If true, then some of the hidden galaxies we are detecting might not be located in our three-dimensional space at all, but rather in some higher dimensional structure that only occasionally interacts with our own. Could it be that some of the galaxies we've found behind the Milky Way are not just hidden by dust, but are in fact slipping in and out of our visible universe due to the warping of space-time? This idea might sound like science fiction, but there are already hints that the universe is far stranger than we ever imagined. Quantum physics tells us that particles can exist in multiple states at once, and general relativity suggests that space-time can be stretched, bent, and possibly even looped back on itself. If the universe is truly as strange as these theories suggest, then the existence of hidden galaxies might only be the beginning. What if some regions of space are permanently cut off from our view, not because of physical obstructions, but because of the fundamental nature of reality itself? And then, there's the question of life. If hidden galaxies have remained undetected for so long, what does that say about the potential for hidden civilizations? We have long searched for extraterrestrial life in the galaxies we can see, but what if some of the most advanced civilizations exist in galaxies we have never even known to look at? Could there be intelligent beings living in the depths of the hidden universe, developing technology, exploring their own cosmic frontiers, and perhaps even wondering if they are alone, just as we do? If these civilizations exist, they may have an entirely different view of the cosmos. They may have evolved in a part of the universe where different physical laws dominate, or where cosmic history unfolded in a completely unique way. They may see structures and forces that we cannot even perceive. Could it be that some of our greatest scientific mysteries, such as the nature of dark matter, the origin of cosmic voids, or the true scale of the universe, are already understood by civilizations hidden behind the dust of the Milky Way? And finally, we must consider the possibility that we, too, are hidden. If our own galaxy has been blocking the view of other galaxies, then the same must be true in reverse. To observers in distant corners of the universe, the Milky Way itself might be an enigma, an unseen mass of stars and planets, lurking behind their own cosmic obstructions. Could it be that alien astronomers are just now discovering us, just as we are uncovering them? Could our own solar system be part of someone else's zone of avoidance? A once hidden region that is only now coming into focus? The idea that entire galaxies, and perhaps entire civilizations, have remained unseen for so long is a humbling reminder of how much we still have to learn. It forces us to confront the limits of our knowledge and to acknowledge that the universe is far more complex, vast, and mysterious than we ever dared to imagine. And if history has taught us anything, it's that every time we think we understand the cosmos, it surprises us. The discovery of hidden galaxies is not the end of the story, it is just the beginning. If the galaxies behind the Milky Way have remained hidden for so long, what does that tell us about the nature of discovery itself? For centuries, humans have believed that they were reaching the limits of what could be known, only to be humbled time and time again by revelations that shattered their assumptions. The realization that massive structures, entire galaxies, have been lurking just beyond our view forces us to reconsider how much of the universe we have yet to uncover. It suggests that the things we take for granted, the boundaries of our cosmic maps, the supposed completeness of our knowledge, are fragile and easily overturned. This isn't just about seeing new galaxies. It's about accepting that the universe may be filled with layers of hidden truths waiting to be revealed. One of the most intriguing aspects of these hidden galaxies is the sheer scale of what we might have missed. The galaxies behind the Milky Way's dust are not just small, unremarkable star clusters. They are enormous, complex structures, some of which rival or even exceed the size of the Milky Way itself. This means that, for decades, our calculations of galactic density, gravitational interactions, and cosmic structures have been based on an incomplete picture. If we've been wrong about something as fundamental as the number of nearby galaxies, what other aspects of astrophysics might need to be re-examined? Consider the Great Attractor, a mysterious gravitational anomaly pulling galaxies, including our own, toward a specific region of space. For years, scientists struggled to explain why so many galaxies appeared to be moving in one direction. The answer, as it turns out, lay partially in the zone of avoidance. Behind the dust and gas of the Milky Way, astronomers discovered hidden galactic clusters that had remained undetected, exerting their gravitational influence without our knowledge. This revelation changed our understanding of cosmic motion and proved that even our best models can be misleading when they lack key pieces of information. But what if the Great Attractor is only one example of a much larger phenomenon? What if, beyond the regions we have explored, there are even greater hidden forces shaping the motion of the cosmos? The implications don't stop at gravity. Hidden galaxies could also change how we understand the evolution of the universe itself. Every major cosmic event, galactic collisions, star formation rates, the distribution of dark matter, depends on our understanding of where matter is located. If vast numbers of galaxies have been missing from our models, then our theories of cosmic history may be fundamentally flawed. Could it be that the structure of the universe is far more interconnected than we realized? Could some of the patterns we see in the distribution of galaxies, what we assumed were random fluctuations, actually be the result of hidden networks of galaxies exerting unseen influence? And what about the possibility of habitable planets in these hidden galaxies? If they contain billions of stars, then they likely contain billions of planets as well. Statistically, at least some of those planets must be located in habitable zones, where conditions could allow for life to exist. The idea that intelligent civilizations could be thriving in galaxies we only recently discovered is both thrilling and humbling. These civilizations might have been watching the stars for as long as we have, unaware that our galaxy even existed, just as we were unaware of theirs. They might be developing their own theories of physics, searching for answers to the same cosmic questions we struggle with, and perhaps even wondering if they are alone in the universe, never realizing that we were hidden behind a curtain of interstellar dust. But let's take this even further. If we have only just begun to uncover hidden galaxies, could there be entire superstructures, massive cosmic formations beyond our comprehension, that remain unseen? Astronomers have long theorized about the existence of vast cosmic walls, enormous sheets of galaxies stretching for billions of light years. Some of these structures, like the Sloan Great Wall, are already known to exist, but what if there are even larger formations still concealed from us? If so, these structures could completely redefine our understanding of how matter is distributed throughout the universe. Even more unsettling is the idea that some regions of the cosmos might be permanently hidden from us, not because of dust, but because of the expansion of the universe itself. As the universe expands, distant galaxies are moving away from us faster and faster, to the point where some of them are receding beyond the cosmic event horizon. Once they pass this threshold, their light will never be able to reach us, no matter how advanced our telescopes become. This means that some galaxies, which may have once been visible, are now effectively erased from our observable universe. Could it be that entire sections of the cosmos, filled with galaxies, stars, and perhaps even civilizations, have already disappeared from our view, lost forever to the relentless expansion of space? If that's the case, then every discovery we make is a race against time. The hidden galaxies behind the Milky Way were always there, waiting for us to find them, but what about the galaxies that won't be there in the future? As the universe expands, the number of galaxies we can observe will continue to shrink. If we do not uncover these hidden cosmic secrets now, we may never get another chance. What mysteries might we miss simply because we waited too long? The thought that we may have already lost access to parts of the universe is deeply unsettling. It means that the history of the cosmos is not just something we uncover, it's something that is actively slipping away. And if we are discovering hidden galaxies now, we must wonder, how many have already vanished beyond the veil, never to be seen again? But the biggest mystery of all remains unanswered. Why is the universe hiding so much from us? Is it simply a matter of perspective, an accident of cosmic alignment? Or is there something deeper at play, some fundamental aspect of reality that keeps certain truths just out of reach? Every time we think we have mapped the universe, it surprises us with something new. And as long as there are mysteries hidden behind the dust, the journey of discovery will never truly be over. The realization that vast portions of the universe have remained hidden for so long forces us to question just how much of reality is still beyond our reach. If galaxies, massive collections of billions of stars, can be concealed behind something as seemingly ordinary as dust, what else might be lurking out of sight? The zone of avoidance was once considered a minor inconvenience, but now it has become a symbol of how much we still don't know. And even though modern technology has begun to peel back the layers, we are still left with more questions than answers. One of the most intriguing possibilities is that our understanding of galactic structures has been incomplete all along. If galaxies are hidden from view, then the maps we've constructed of the observable universe might be missing key elements. The cosmic web, the large-scale structure of the universe, in which galaxies form filaments and clusters, may be far more interconnected than we thought. What if some of the most massive structures in the universe have been hiding right in front of us, influencing cosmic movements in ways we've yet to comprehend? This could have profound implications for our understanding of dark matter. Astronomers have long been puzzled by the gravitational effects observed in galaxies and galaxy clusters, which don't seem to match up with the amount of visible matter. The existence of dark matter was proposed as an explanation, an invisible, undetectable form of mass that interacts only through gravity. But what if some of these gravitational anomalies can be explained by hidden galaxies instead? If we've underestimated the number of galaxies in our cosmic neighborhood, then perhaps some of the gravitational forces we attributed to dark matter were actually coming from massive structures concealed by the Milky Way's dust. That doesn't mean dark matter doesn't exist, far from it. But it does suggest that our calculations may need to be revised. If hidden galaxies account for even a small percentage of the missing mass, it could change the way we approach the dark matter problem entirely. Could it be that our galaxy itself is resting in the gravitational pull of an enormous but previously undetected cosmic structure? Could the forces that shape our local group of galaxies be tied to something we've only just begun to uncover? And what about cosmic radiation? Our galaxy is constantly bombarded by high-energy cosmic rays from distant sources, some of which remain unidentified. Scientists have long debated the origins of these ultra-high-energy particles, wondering if they come from supermassive black holes, gamma-ray bursts, or even exotic physics beyond the standard model. But what if some of them are coming from galaxies we haven't seen until now? If powerful cosmic events, like supernovae, quasars, and black hole jets, are occurring in these hidden galaxies, then they may be contributing to the radiation that reaches Earth. This raises another unsettling question. If hidden galaxies can influence our cosmic environment in ways we didn't expect, could they also be affecting the Milky Way itself? Galaxies interact with each other in ways that go far beyond gravity. They exchange gas, radiation, and even stars. Some galaxies have been observed pulling material away from their neighbors, triggering new waves of star formation or even accelerating the death of certain stellar regions. If there are hidden galaxies near us, is it possible that they have already been shaping the Milky Way's history without us even realizing it? Consider the phenomenon of galactic mergers. When two galaxies collide, their structures are disrupted, stars are thrown into new orbits, and supermassive black holes can be triggered into activity. The Milky Way is already on a collision course with the Andromeda Galaxy. But what if there are other, smaller galaxies hiding nearby, waiting to interact with us? Could some of them be slowly merging with the Milky Way right now, contributing to unexplained movements of stars and gas? If that's the case, then studying these hidden galaxies isn't just about curiosity. It's about understanding our own future. If a hidden galaxy is on a trajectory that will one day bring it into contact with the Milky Way, we need to know about it. Such a collision could reshape our galaxy, trigger new waves of star formation, or even alter the environment of our solar system. But beyond the scientific implications, the discovery of hidden galaxies forces us to confront a deeper question. How much of the universe have we simply failed to see? If entire galaxies can be concealed, what else is out there that remains beyond our grasp? Could there be cosmic structures so vast, so strange, that we haven't even begun to comprehend them? And if so, are we looking in the right places? It's easy to assume that with advanced telescopes and cutting-edge technology, we have mapped the universe with a high degree of accuracy. But history has shown that every time we think we have a complete picture, the universe surprises us. Just as early astronomers once believed the Milky Way was the entire universe, only to later discover billions of other galaxies, we may be on the verge of another revelation, one that changes the way we perceive the cosmos itself. And so, as we continue to uncover the secrets of these hidden galaxies, we are left with a tantalizing possibility. What if the universe is far larger, far stranger, and far more interconnected than we ever imagined? What if the true nature of reality is still just out of reach, waiting for the next great discovery to bring it into focus? If hidden galaxies have been affecting the Milky Way without our knowledge, then the implications stretch beyond astronomy. They reach into the very fabric of how we understand cosmic evolution. Galaxies do not exist in isolation. They are shaped by gravitational forces, intergalactic interactions, and even vast cosmic flows that move through the universe like invisible currents. If there are hidden galaxies lurking behind the Milky Way's dust, then they might not just be passive objects. We might be caught in their gravitational influence without even realizing it. Consider the Great Attractor, a mysterious region of space that seems to be pulling thousands of galaxies, including the Milky Way, toward it. For decades, astronomers have struggled to pinpoint what exactly is causing this immense gravitational pull. Some theories suggest it is a massive concentration of galaxy clusters, while others propose that unknown dark matter structures are playing a role. But what if part of the answer lies in the hidden galaxies behind the zone of avoidance? If these galaxies are large enough, their combined mass could significantly contribute to the gravitational forces shaping our galactic neighborhood. The idea that there might be entire structures hidden from our view but actively influencing our motion through space is both unsettling and exhilarating. It suggests that our understanding of cosmic dynamics has been missing a crucial piece of the puzzle. But there is another layer to this mystery, one that goes beyond simple gravitational pull. Hidden galaxies might also be part of something even bigger, vast, interconnected networks of matter that stretch across the universe in ways we have barely begun to comprehend. The concept of the cosmic web, the idea that galaxies are arranged in a vast, interconnected structure of filaments and voids, has revolutionized our understanding of the cosmos. If hidden galaxies are nestled within these filaments, then they might be affecting the flow of matter and energy on a scale we have never imagined. This raises profound questions about the role of hidden structures in shaping the history of the universe itself. If entire galactic clusters have remained unseen, could they be influencing cosmic expansion in ways we haven't accounted for? Could they be distorting our measurements of the universe's age, composition, or even its fundamental laws? For example, the Hubble constant, a value that describes the rate at which the universe is expanding, has been one of the most contentious measurements in modern astrophysics. Different methods of calculating it yield different results, leading to what is known as the Hubble tension. Some scientists believe this discrepancy hints at new physics, while others suspect observational biases. But what if some of this inconsistency is due to hidden galaxies affecting our calculations? If unseen mass is warping the light we observe, or if we have been underestimating the total number of galaxies in the universe, then our understanding of cosmic expansion might need to be re-evaluated. And then there is the question of time itself. If galaxies can remain hidden for billions of years, only to be revealed by new observational techniques, then what else is waiting to be discovered? What if some of the most fundamental assumptions we have made about the universe are based on incomplete data? One possibility is that hidden galaxies could help us solve another long-standing cosmic mystery, the origin of fast radio bursts, FRBs. These are incredibly powerful, millisecond-long pulses of radio waves that originate from distant galaxies, but their exact cause remains unknown. Some FRBs come from known galaxies, but many appear to originate from places with no visible source. Could it be that some of them are coming from hidden galaxies we have not yet detected? If so, studying these galaxies could offer critical insights into the nature of these enigmatic cosmic signals. This brings us back to a fundamental truth about space exploration. Every time we think we have reached the limits of what we can see, the universe proves us wrong. The discovery of hidden galaxies is not just about finding more stars or mapping more structures. It is about challenging our assumptions and pushing the boundaries of human knowledge. It is a reminder that even with all our technology, all our theories, and all our observations, we are still in the early stages of understanding the cosmos. And perhaps that is the most exciting part of all. The fact that we are still uncovering fundamental truths about the universe means that the greatest discoveries may still be ahead of us. If entire galaxies have remained unseen for so long, then what else is waiting in the shadows, hidden behind cosmic dust, lurking in the depths of space? The next breakthrough could change everything we know about the universe, and perhaps even our place within it. If hidden galaxies exist beyond the Milky Way's dust, they may not just be isolated celestial objects, they could be part of a much larger, interconnected cosmic structure that has been shaping our galaxy's history without our awareness. When astronomers first realized that entire galaxies could be concealed behind the thick veil of cosmic dust, it became clear that our perception of the universe was incomplete. The Milky Way's dense disk has been obstructing our view, hiding what could be entire galactic clusters, star-forming regions, and even gravitational influences that subtly but profoundly affect our cosmic neighborhood. The possibility that we are being gravitationally influenced by unseen galaxies is an unsettling realization. The Great Attractor, the Laniakea supercluster, and the Shapley supercluster are all regions of immense mass that seem to be pulling the Milky Way and its neighboring galaxies toward them. But what if part of that pull is coming from structures we haven't even mapped yet? If hidden galaxies exist in significant numbers behind the Milky Way's dust, then our calculations about the mass distribution of the universe could be incomplete. This would mean that our entire understanding of cosmic motion, large-scale structures, and gravitational dynamics may need revision. What's even more fascinating is that these galaxies, obscured for billions of years, could hold critical information about the early universe. The light from these hidden structures has traveled for millions or even billions of years to reach us. Some of these galaxies may have formed shortly after the Big Bang, and they could provide vital clues about the universe's infancy. Studying them could help answer long-standing questions about galaxy formation, the evolution of cosmic structures, and even the nature of dark matter. One of the most mind-boggling implications of these hidden galaxies is their potential connection to dark matter. Dark matter is one of the greatest unsolved mysteries in modern physics. It makes up about 27% of the universe, yet we cannot see or directly detect it. We only know it exists because of its gravitational effects on visible matter. But what if part of what we perceive as dark matter is actually regular matter hidden behind cosmic dust? If a significant number of galaxies have been hidden from view, then our estimates of the amount of dark matter in the universe might need to be adjusted. But let's take this even further. If entire galaxies have remained undetected, then we must ask, what else is hiding in the cosmos? Could there be entire galactic civilizations, unknown cosmic phenomena, or even alternative forms of physics waiting to be uncovered? Our current observations of the universe are based on the assumption that what we see is a representative sample of reality. But if the zone of avoidance has been hiding entire galaxies, then our understanding of the universe might be based on an incomplete dataset. This realization forces us to rethink our approach to astrophysics and cosmology. Every time we push the boundaries of observation, we discover something new, something that challenges what we thought we knew. The hidden galaxies behind the Milky Way's dust are a perfect example of this. For centuries, we assumed that our view of the universe was comprehensive. Now we are beginning to understand that we have only been seeing a fraction of what truly exists. And here's the most exciting part. With the development of next-generation telescopes, we are on the verge of uncovering more hidden structures than ever before. The James Webb Space Telescope, JWST, has already revolutionized our ability to peer into the depths of space, revealing galaxies that were previously invisible to us. Future telescopes, equipped with even more advanced infrared and radio capabilities, will allow us to see through the dust and finally map these hidden galaxies with unprecedented detail. Imagine what we might find. Perhaps we will discover new types of galaxies that defy our current classifications. Perhaps we will uncover cosmic megastructures that challenge our understanding of how galaxies interact. Or maybe, just maybe, we will find evidence of something truly groundbreaking, something that changes our fundamental understanding of reality itself. And that's the beauty of space exploration. The more we discover, the more questions arise. The hidden galaxies behind the Milky Way's dust are not just a scientific curiosity. They are a reminder that the universe is far more mysterious, far more complex, and far more awe-inspiring than we ever imagined. If entire galaxies have been hidden from us, then everything we think we know about the universe might be built on an incomplete foundation. Think about that for a moment. Every single model of cosmic evolution, every theory about the large-scale structure of the universe, and every assumption we've made about galactic distribution might need to be re-evaluated. We have always assumed that the observable universe gives us a relatively complete picture of cosmic structures. But what if what we see is just a fraction of what truly exists? The discovery of hidden galaxies suggests that we have been missing an entire piece of the puzzle, a missing chapter in the story of the universe that we never even knew was there. The implications of this are staggering. Galaxies are not just scattered randomly across the universe. They are part of vast cosmic structures, woven into the fabric of the universe like an intricate web. This cosmic web is composed of immense filaments of galaxies stretching across billions of light years, interconnected by gravitational forces that shape the evolution of everything within it. But if entire galactic clusters have been concealed behind the Milky Way's dust, then the structure of this cosmic web may be different from what we currently believe. What if we are not seeing the full extent of the filaments? What if entire sections of the cosmic web have been hidden, distorting our understanding of how the universe evolved? This raises another question. If hidden galaxies exist in significant numbers, how much do they contribute to the total mass of the universe? Right now, our estimates of the universe's total mass are based on what we can observe. But if there are far more galaxies than we previously accounted for, then those estimates might be wrong. This could have profound implications for our understanding of cosmic expansion, dark matter, and even the fate of the universe itself. The universe's expansion rate, for example, is measured using observations of galaxies at different distances. If hidden galaxies are influencing those measurements in ways we haven't accounted for, then our entire model of cosmic expansion might need to be revised. Could it be that we are underestimating the true density of the universe? Could the presence of these hidden galaxies affect the way we interpret the cosmic microwave background radiation, the afterglow of the Big Bang? And what about the mysterious nature of dark energy, the force that is accelerating the expansion of the universe? Dark energy is one of the biggest mysteries in physics, and it is estimated to make up nearly 70% of the universe's total energy. But what if some of what we attribute to dark energy is actually an observational bias caused by the existence of hidden galaxies? If there are vast structures we have not yet accounted for, could they be affecting our measurements of cosmic acceleration? Could they be altering the distribution of galaxies in ways that mimic the effects of dark energy? Then there's the question of time. The light from these hidden galaxies has been traveling for billions of years to reach us, meaning that when we finally detect them, we are seeing them as they were in the distant past. If they have been concealed behind dust for billions of years, then they could provide a window into a previously unseen era of cosmic history. This could be revolutionary for our understanding of how galaxies formed and evolved over time. Were these hidden galaxies different from the ones we can see? Did they follow the same patterns of star formation, or were they shaped by unique cosmic conditions that we have never observed before? But let's take this even further. If hidden galaxies exist in large numbers, then what else could be hiding in the universe? Could there be entire regions of space where our observations are limited by factors we have not even considered yet? Could there be cosmic phenomena, massive structures, undiscovered celestial objects, or even exotic forms of matter that have remained unseen simply because of the limitations of our current technology? Every time we develop a new observational technique, we discover something unexpected. What if the greatest discoveries of all time are still waiting for us, hidden just beyond the limits of what we can currently see? And then there's the question that every scientist, astronomer, and space enthusiast secretly wonders about. What if these hidden galaxies harbor something truly unexpected? If we have been missing entire galaxies, then we have also been missing the potential for planetary systems, exoplanets, and even, possibly, extraterrestrial life. What if the search for life in the universe has been looking in the wrong places all along? We have been scanning the skies, searching for habitable planets and signs of intelligent civilizations, But what if some of the most promising candidates have been hidden from us this entire time? If there are star systems within these galaxies that we have never seen, then it is possible that planets orbiting those stars have remained undetected as well. Could these hidden galaxies be home to planets with conditions suitable for life? Could we be on the verge of discovering entire ecosystems in places we never even knew existed? The realization that entire galaxies have been hiding in plain sight is a humbling reminder of how little we truly know. For centuries, humanity has looked up at the night sky and imagined that we understood the cosmos. But every time we think we have reached the limits of our knowledge, the universe proves us wrong. The hidden galaxies behind the Milky Way's dust are not just a new discovery, they are a wake-up call. They remind us that the universe is still full of secrets, that our cosmic journey is far from over, and that the greatest discoveries may still be ahead of us. The next breakthrough could be just around the corner, waiting for the right telescope, the right observation, or the right moment of insight to reveal itself. And when that moment comes, it will change everything. Because the more we learn about the universe, the more we realize that we are only just beginning to scratch the surface of its mysteries. Hidden galaxies are just the start. What else is waiting to be uncovered? What other cosmic wonders are still hiding in the depths of space, waiting for us to find them? The answer may be out there, just beyond the reach of our current knowledge, waiting for the next generation of explorers to bring it into the light. The existence of hidden galaxies forces us to reconsider a fundamental question: how much of the universe have we truly seen? If we've missed entire galaxies for so long, it raises the unsettling possibility that we are still only seeing a fraction of the cosmos. The observable universe, as vast as it may seem, is just the part of space from which light has had time to reach us. But if entire galactic structures have remained undetected simply because of a veil of dust, what other cosmic phenomena might be hidden in ways we haven't even imagined? One of the biggest challenges in astrophysics is distinguishing between what we can't see because it's too far away and what we can't see because something is blocking our view. The discovery of hidden galaxies behind the Milky Way's dust suggests that our current maps of the universe might be significantly incomplete. Astronomers rely on massive sky surveys to chart the locations of galaxies and build models of cosmic evolution. But if these surveys have been missing vast numbers of galaxies, then our understanding of the large-scale structure of the universe may be skewed. The so-called zone of avoidance, the region obscured by our own galaxy, has long been a blind spot in our observations, but now we are beginning to uncover what lies beyond it. The zone of avoidance is a region where the dense clouds of gas and dust within the Milky Way make it nearly impossible for optical telescopes to see beyond. This has left a significant gap in our cosmic maps, with entire galaxies hidden from view. But with the advent of infrared and radio astronomy, scientists have started to pierce through the veil, revealing a hidden cosmic landscape that was previously invisible. Some of the first discoveries of hidden galaxies came from radio telescopes, which can detect the neutral hydrogen gas present in galaxies, even when dust obscures their stars. Infrared telescopes, like NASA's Spitzer Space Telescope and the European Space Agency's Herschel Space Observatory, have also played a crucial role, as infrared light can penetrate dust and reveal structures that optical telescopes cannot detect. What we have found so far is just the beginning. Some of these hidden galaxies are part of massive galactic clusters, structures so large that they challenge our understanding of cosmic evolution. One such discovery was the Vela supercluster, a gigantic collection of galaxies that had remained unseen until astronomers used specialized telescopes to look beyond the Milky Way's dust. The sheer size of this structure suggests that it has a gravitational influence on our own galaxy, potentially affecting the motion of the Milky Way itself. If such immense structures have remained hidden for so long, what else might be lurking just beyond our view? The existence of hidden galaxies also forces us to rethink the concept of dark matter. Dark matter is a mysterious form of mass that does not emit, absorb, or reflect light, yet its gravitational effects can be observed on large cosmic scales. It is estimated that dark matter makes up about 85% of the total mass of the universe, yet no one has ever directly detected it. But what if some of the mass attributed to dark matter is actually hidden galaxies that we simply hadn't seen before? Could it be that at least part of the missing mass of the universe is not some exotic, invisible substance, but rather ordinary galaxies that have been obscured by cosmic dust? If this is the case, then our entire understanding of dark matter could be due for a major revision. Current theories suggest that dark matter forms vast halos around galaxies, influencing their rotation speeds and clustering them into the large-scale structures we observe today. But if a significant number of galaxies have been hidden from view, then our calculations of how much dark matter is needed to explain these structures might be off. This could mean that we need to rework our models of galaxy formation and evolution, incorporating the influence of these hidden galaxies into our understanding of how the universe has developed over billions of years. Another profound implication of hidden galaxies is their potential to reshape our understanding of cosmic voids. Cosmic voids are vast, empty regions of space that contain very few galaxies, forming the dark spaces between the filaments of the cosmic web. These voids are thought to be some of the oldest structures in the universe, regions where matter simply never accumulated in large quantities. But if we have been missing entire galaxies, then could it be that some of these so-called voids are not actually empty, but rather filled with galaxies that have simply been hidden from our view? If that's the case, then the distribution of matter in the universe may be very different from what we currently believe. The cosmic web could be even more interconnected than we previously thought, with hidden filaments and clusters of galaxies filling in gaps we assumed were empty. This would have major implications for our understanding of how the universe evolved from the hot, dense state of the Big Bang into the vast cosmic landscape we see today. It would also affect our models of how galaxies move and interact with one another, as hidden gravitational forces from unseen structures could be shaping the cosmos in ways we have not yet realized. But perhaps the most exciting possibility of all is what these hidden galaxies could tell us about the potential for life elsewhere in the universe. Every galaxy contains billions or even trillions of stars, many of which have planets orbiting them. If we have only been studying a fraction of the galaxies that actually exist, then we have also been overlooking countless potential habitable worlds. These hidden galaxies could contain planets with conditions suitable for life, and if intelligent civilizations exist beyond Earth, they might be located in places we have never even considered looking. The search for extraterrestrial life has long been constrained by our ability to detect exoplanets around visible stars. But if there are hidden galaxies, then there could also be hidden star systems, worlds orbiting stars that have been obscured by cosmic dust, waiting to be discovered. This raises an incredible possibility. What if our search for alien life has been hindered not by the lack of extraterrestrial civilizations, but by the limitations of our own observational tools? Could it be that signals from intelligent civilizations have been traveling through space, unnoticed, simply because we have not been looking in the right places? As technology continues to advance, we are entering a new era of astronomy, one where the hidden corners of the universe are finally coming into view. Future telescopes, like the James Webb Space Telescope and the Square Kilometre Array, will be able to peer through cosmic dust with unprecedented precision, revealing more hidden galaxies than ever before. These discoveries will not only expand our understanding of the universe, but they may also force us to rethink some of the most fundamental questions in cosmology. The fact that entire galaxies have remained hidden from us for so long is a powerful reminder that the universe is still full of mysteries. Every time we think we have reached the limits of our knowledge, the cosmos surprises us with something new. The discovery of hidden galaxies is not just a new chapter in the story of astronomy. It is the opening of an entirely new book, one that promises to challenge everything we thought we knew about the nature of the universe. And the most incredible part? We are only just beginning to scratch the surface. If we have already found galaxies that have remained invisible for so long, then what other cosmic secrets might still be hiding in the darkness? Could there be even larger structures waiting to be discovered? Could there be new types of celestial objects that we have never seen before? Could the very nature of space itself hold surprises beyond our wildest imagination? The search for hidden galaxies is not just about finding what has been obscured by dust. It is about revealing the true nature of the cosmos, piece by piece, until we finally see the universe as it really is. And as we continue this journey, one thing is certain: the universe is far bigger, far stranger, and far more full of wonders than we ever dared to believe. The realization that we have missed entire galaxies due to cosmic dust leads to an even deeper question. How do we truly define the limits of what we can see? If entire structures as massive as the Vela supercluster have remained hidden from our view, what does that say about the way we map and understand the universe? The fact that we are only now uncovering these hidden galaxies suggests that there may be even more unknowns lurking in the depths of space, waiting for the right tools and techniques to reveal them. It forces us to reconsider the nature of observational limitations, as well as the biases in our understanding of cosmic evolution. Astronomy has always been an evolving science, shaped by the technologies available at any given time. In the past, before the invention of the telescope, people believed the night sky consisted only of stars visible to the naked eye. Then, as telescopes improved, our understanding expanded to include planets, nebulae, and galaxies. But even now, with some of the most advanced observatories ever built, we are still uncovering entire galaxies that have remained unseen for millennia. This raises an important question: are there even greater cosmic structures, beyond anything we can currently detect, hidden not just by dust, but by the limitations of our understanding? One possibility is that hidden galaxies are just the beginning. If dust can obscure entire galactic clusters, then what other cosmic barriers might be preventing us from seeing the true structure of the universe? Could there be regions of space that are not just hidden by dust, but by more exotic forms of matter? The idea of cosmic censorship, where certain parts of the universe are hidden from our view due to the very nature of space-time, has been proposed by some physicists as a possible explanation for why we seem to be missing so much of the universe's mass and energy. This ties into the ongoing mystery of dark matter and dark energy. We know that galaxies rotate faster than they should based on the visible matter they contain, leading to the conclusion that there must be some unseen mass holding them together, what we call dark matter. But what if some of that missing mass is simply hidden from view due to extreme cosmic obstructions? If dust can hide galaxies, could other, more exotic forms of cosmic matter be hiding entire regions of space? Could there be hidden galactic superstructures that have remained undetected, not because they are absent, but because we lack the ability to see them? This concept forces us to rethink our cosmic blind spots. The zone of avoidance, for example, has long been considered an observational limitation, a region where our galaxy's dust prevents us from seeing what lies beyond. But what if there are other zones of avoidance in the universe? Regions where different cosmic phenomena obscure entire galaxies, superclusters, or even stranger objects? If such hidden regions exist, then our current cosmic maps might only represent a fraction of what is actually out there. Beyond the structural implications, the existence of hidden galaxies also has profound consequences for our understanding of cosmic history. If we have been missing a significant portion of the universe's galaxies, then our models of galaxy formation and evolution may need to be revised. Current theories suggest that galaxies form within vast clouds of gas and dust, gradually growing as they pull in more matter and merge with other galaxies. But if there are hidden galaxies that do not follow the expected distribution patterns, then we might need to rethink how galaxies form and evolve over billions of years. For instance, the discovery of the Vela supercluster suggests that there are massive, interconnected structures that we have been unaware of. If more hidden superclusters are uncovered, it could challenge our current understanding of how matter is distributed in the universe. It could mean that the large-scale structure of the cosmos is far more complex than previously thought, with massive, hidden filaments of galaxies stretching across vast distances in ways we have yet to comprehend. This also raises the question of what lies beyond even the hidden galaxies we have discovered. Could there be entire regions of the universe that are inaccessible to us, not just because of dust, but due to the fundamental nature of space-time itself? Some physicists speculate that there could be cosmic regions separated from our own by vast voids, gravitational anomalies, or even distortions in space-time that make them invisible to our instruments. If such hidden regions exist, they could represent a new frontier in our quest to understand the universe. Another intriguing implication of hidden galaxies is the possibility that they could contain unknown cosmic phenomena. If these galaxies have remained unseen for so long, then what else might be hidden within them? Could they harbor exotic forms of matter, unknown types of celestial objects, or even new kinds of astrophysical processes that we have never observed before? The idea that entire galaxies could have developed in relative isolation, shielded from our view, opens up the possibility that they might have followed entirely different evolutionary paths than the galaxies we are familiar with. One of the most fascinating possibilities is that these hidden galaxies could contain unique planetary systems, some of which may be capable of supporting life. If our own galaxy's dust has been hiding other galaxies, then it has also been hiding countless stars and their accompanying planets. This means that the total number of potentially habitable worlds in the universe could be far higher than we previously estimated. The discovery of hidden galaxies could therefore have major implications for the search for extraterrestrial life, suggesting that the cosmic real estate available for life is far greater than we ever imagined. This brings us back to one of the most profound questions in science. Are we alone in the universe? If the number of galaxies is even higher than we thought, then the probability of life elsewhere increases dramatically. Scientists have long used the Drake equation to estimate the likelihood of extraterrestrial civilizations, but if we have been underestimating the number of galaxies, then every calculation based on that equation may need to be revised. Could it be that intelligent civilizations have already emerged in some of these hidden galaxies, completely unnoticed by us? Could we one day develop the technology to peer beyond the cosmic dust and detect signs of life in places we never even knew existed? Advancements in observational technology will be key to answering these questions. The James Webb Space Telescope, for example, is designed to observe the universe in infrared wavelengths, allowing it to see through dust and reveal structures that were previously hidden. Future radio and gravitational wave observatories may also help us uncover more of these hidden galaxies, painting a more complete picture of the universe. As our ability to observe improves, we may find that the cosmos is even more dynamic and filled with hidden wonders than we ever imagined. Ultimately, the discovery of hidden galaxies is a reminder that the universe is still full of surprises. No matter how much we think we know, there is always more to uncover. The fact that entire galaxies have remained unseen for so long suggests that we are still in the early stages of truly understanding the cosmos. Every new discovery adds another piece to the puzzle, revealing a universe that is far richer and more complex than we ever dreamed. And yet, for all we have uncovered, the greatest mysteries may still lie ahead. If we have missed something as vast as hidden galaxies, then what else could be out there, waiting to be discovered? Could there be new types of cosmic structures that defy our current understanding? Could there be regions of the universe where the laws of physics themselves operate differently? Could we one day uncover something so unexpected that it forces us to rethink everything we know about reality? The universe is not just vast, it is layered with mysteries, some of which we are only now beginning to perceive. The search for hidden galaxies is not just a search for missing pieces of the cosmic puzzle. It is a quest to uncover the true nature of the universe itself. As we continue to push the boundaries of our knowledge, one thing becomes clear. The cosmos is far greater, far more complex, and far more filled with hidden wonders than we ever imagined. And the more we discover, the more we realize that we have only just begun to understand the infinite mysteries of space. The discovery of hidden galaxies is not just a matter of improving our ability to see through dust. It is a fundamental shift in how we perceive the universe. If entire superclusters have been hidden from us, then the way we have been mapping the cosmos might be fundamentally flawed. Our current understanding of the universe's structure is built on the assumption that we can see most of what is out there. But what if that assumption is incorrect? What if the universe we think we know is just the visible tip of a far larger, more complex cosmic iceberg? Consider the implications this has on our understanding of cosmic expansion. The Big Bang Theory tells us that the universe has been expanding ever since its inception, with galaxies moving apart over time. But if a significant portion of the universe has been hidden from view, then our measurements of cosmic expansion could be incomplete. We rely on observations of galaxies to determine how fast the universe is expanding, but if we are missing entire clusters, then our calculations might be off. Could the discovery of hidden galaxies lead to a revision of our understanding of cosmic expansion? Could it even force us to rethink some of the fundamental principles of cosmology? The idea that we might be missing large portions of the universe also has implications for the so-called missing mass problem. Astronomers have long known that the amount of visible matter in the universe does not account for the way galaxies behave. This led to the theory of dark matter, a mysterious, unseen substance that is thought to make up most of the universe's mass. But what if some of that missing mass is not dark matter at all? What if it is simply hidden galaxies and structures that we have not yet detected? If so, then the true distribution of matter in the universe might be far more intricate than we previously thought. This also raises the possibility that some of our other cosmic observations may be incomplete. For example, the cosmic microwave background radiation, the afterglow of the Big Bang, is one of the most important pieces of evidence for our understanding of the early universe. But if we have been missing entire galaxies due to dust, then what else might we be missing in our measurements of the universe's background radiation? Could our understanding of the early universe be incomplete because we have been looking at an obscured and distorted picture of reality? The problem of hidden galaxies is not just an issue of astronomical observation, it is a fundamental challenge to our perception of reality itself. We like to believe that with the right tools, we can uncover the true nature of the universe. But what if the universe is structured in such a way that some parts of it will always remain hidden? Could it be that there are regions of space that are forever beyond our reach, not because of technological limitations, but because of the very nature of space and time? One of the most intriguing possibilities is that hidden galaxies might contain entirely different types of celestial objects than what we are used to seeing. If these galaxies have remained unseen for billions of years, then they may have evolved under very different conditions than the galaxies we have studied. Could there be stars with properties unlike any we have encountered? Could there be exotic forms of matter or even new types of astrophysical processes that we have never observed? This idea ties into the concept of cosmic diversity. We tend to assume that most galaxies follow a similar pattern, spiral, elliptical, or irregular in shape, with stars and planets forming in predictable ways. But what if there are entire classes of galaxies that have remained hidden from us, with structures and behaviors that challenge our understanding? Could there be galaxies where star formation works in an entirely different way? Could there be regions of space where the laws of physics behave differently than we expect? One of the biggest mysteries surrounding hidden galaxies is their potential role in the cosmic web. The universe is not just a random scattering of galaxies. It is structured like a vast cosmic web, with filaments of galaxies stretching across immense distances and connecting into massive superclusters. The discovery of hidden galaxies suggests that this web may be far more intricate than we previously thought. Could it be that we have been looking at an incomplete version of the cosmic web, missing key connections that shape the way matter is distributed on the largest scales? If so, then our understanding of how the universe formed and evolved may need to be re-evaluated. The cosmic web is thought to have formed from tiny fluctuations in the density of the early universe, which later grew into the massive structures we see today. But if we have been missing entire sections of this web, then our models of cosmic evolution may be incomplete. Could it be that some of the forces shaping the universe are more complex than we realize? Could there be hidden interactions between galaxies that we have not yet detected? This brings us to one of the most profound questions of all. What else is hiding in the depths of space? If we have missed entire galaxies, then what other cosmic structures might be lurking beyond our current field of view? Could there be undiscovered types of celestial bodies, new kinds of stars, planets, or even black holes that operate in ways we do not yet understand? Could there be massive cosmic voids or unseen gravitational forces that shape the universe in ways we have yet to grasp? Perhaps the most exciting implication of hidden galaxies is their potential for hosting unknown forms of life. If these galaxies contain billions of unseen stars, then they also contain billions of unseen planets. And if we have underestimated the number of galaxies in the universe, then we have also underestimated the number of potentially habitable worlds. The search for extraterrestrial life has always been based on the assumption that life could exist on planets orbiting stars in known galaxies. But what if entire hidden galaxies contain civilizations we have never even imagined? This raises a haunting possibility. Could intelligent life be watching us from one of these hidden galaxies, just as we are now beginning to uncover their existence? If an advanced civilization developed in a galaxy obscured by cosmic dust, they might have been aware of us long before we were aware of them. They may have observed our development, watched as we built telescopes, and even detected our radio signals, all while remaining invisible to us. The idea that we could be under observation from an unseen civilization is both thrilling and unsettling. The discovery of hidden galaxies forces us to confront a deeper truth about the nature of exploration. Every time we think we have mapped the universe, we find that there is more to discover. The realization that we have missed entire galaxies suggests that our cosmic journey is still in its infancy. What other surprises await us? Could there be galaxies made of entirely different materials than those we know? Could there be cosmic structures that challenge the very foundations of physics? In many ways, the discovery of hidden galaxies is a reminder of how little we truly understand about the universe. For centuries, we have looked up at the night sky and believed that we were seeing the cosmos in its entirety. But now, we know that there are entire regions of space we have never seen, filled with mysteries beyond our imagination. The more we uncover, the more we realize that the universe is not just vast, it is layered with secrets, waiting to be revealed. And yet, for all the discoveries we have made, the greatest mysteries still lie ahead. The search for hidden galaxies is not just a scientific endeavor, it is a journey into the unknown. As we continue to push the boundaries of our knowledge, one thing becomes clear: the cosmos is far greater, far more complex, and far more filled with hidden wonders than we ever imagined. And the more we discover, the more we realize that we have only just begun to understand the infinite mysteries of space. The realization that we have been missing entire galaxies behind the thick veil of cosmic dust is both shocking and transformative. It challenges the very foundation of modern astronomy, our ability to map and understand the large-scale structure of the universe. For decades, astronomers have been piecing together a cosmic map based on the assumption that we could see most of what exists, but this assumption is now crumbling. The zone of avoidance, the region of space blocked by the Milky Way's dense dust and gas, has long been a blind spot in our observations. We assumed it was mostly empty or at least unremarkable. But now we know that assumption was wrong. Hidden behind the Milky Way's dust is not just a few stray stars or insignificant clusters, but entire galaxies, some of which rival the size of our own. What makes this discovery even more astonishing is that it is only the beginning. The hidden galaxies we have uncovered so far are likely just a fraction of what truly lies beyond the Milky Way's dense disk. When we think about the implications, the scale is almost unimaginable. Astronomers estimate that there are over 2 trillion galaxies in the observable universe. And yet, if we have been blind to a significant number of them in our own cosmic backyard, then how many more might we be missing across the entire universe? If entire galaxies can hide behind a relatively small region of dust in our own galaxy, then what if similar obstructions exist elsewhere in the cosmos? Could there be vast unseen regions of the universe that remain forever obscured from view? The galaxies hidden behind the Milky Way's dust are not just ordinary galaxies. They hold the potential to reshape our understanding of galaxy formation and evolution. The ones we have discovered so far show unique properties that suggest they have been evolving in isolation, shielded from direct interactions with our own galaxy. This raises profound questions. Have these galaxies developed under different conditions than those we typically observe? Could they contain unusual types of stars, rare cosmic phenomena, or even different fundamental compositions of matter? If the galaxies we see in the open sky represent only a subset of all possible galaxy types, then these hidden galaxies may contain the missing pieces to our understanding of cosmic diversity. One of the most mind-bending aspects of this discovery is how it challenges our perception of distance and scale in the universe. When we observe galaxies in deep space, we are looking across billions of light years, seeing ancient light that has traveled for eons to reach us. But these hidden galaxies are not billions of light years away. They are right next to us, cosmically speaking, separated by a mere few 100 million light years at most. In galactic terms, they are practically neighbors. The fact that they have remained hidden for so long despite their relative proximity is a reminder of how easily cosmic structures can elude our detection. It makes us wonder, what else is lurking just beyond our current observational limits? Another groundbreaking implication of this discovery is its potential impact on the study of dark matter. Dark matter is one of the biggest mysteries in astrophysics, accounting for roughly 85% of the universe's total mass. We infer its existence based on the gravitational effects it exerts on galaxies and galaxy clusters. But if our observations have been incomplete due to hidden galaxies, then our calculations about dark matter could be off. Some of the gravitational effects we attribute to dark matter might actually be coming from unseen, hidden galaxies. This raises the possibility that the distribution of dark matter in the universe is even more complex than we currently believe. Moreover, these hidden galaxies might hold clues about one of the longest-standing mysteries in cosmology, the Great Attractor. The Great Attractor is an enormous gravitational anomaly pulling entire galaxy clusters, including our own local group, toward it at incredible speeds. Scientists have struggled to understand what lies at the heart of this gravitational pull, but many believe it is partially hidden behind the zone of avoidance. Now, with the discovery of previously unseen galaxies, we might finally be on the verge of understanding what is really pulling us toward this mysterious region of space. As we develop more advanced telescopes and computational techniques, our ability to uncover hidden galaxies is improving. Infrared telescopes, in particular, have been instrumental in this discovery. Unlike visible light, which is easily blocked by dust, infrared light can penetrate these obscured regions and reveal what lies beyond. The Hubble Space Telescope's infrared instruments have provided glimpses of hidden galaxies, but it is the upcoming generation of telescopes, like the James Webb Space Telescope, that will truly revolutionize our ability to explore these obscured regions. With its unparalleled infrared sensitivity, James Webb has the potential to uncover not just more hidden galaxies, but also details about their structure, composition, and formation history. But even with advanced telescopes, there are limits to what we can see. The cosmic dust that hides these galaxies is not just a passive barrier, it is an active, dynamic substance that interacts with light in complex ways. The dust itself absorbs, scatters, and re-emits radiation, creating a confusing signal that makes it difficult to distinguish real galaxies from false detections. Scientists have had to develop sophisticated computational models to separate the true signals from the noise. This means that even as we discover more hidden galaxies, we must constantly refine our techniques to ensure we are not being misled by distortions in the data. What makes this discovery even more exciting is the possibility that some of these hidden galaxies may have unusual physical properties. If they have remained isolated for billions of years, they may contain ancient stars that have survived from the earliest epochs of the universe. These stars, known as population 3 stars, are thought to be the first generation of stars that formed after the Big Bang. They are incredibly rare and difficult to find, but hidden galaxies could be prime locations for them to exist. If we can confirm the presence of population 3 stars in these galaxies, it would provide an unprecedented window into the conditions of the early universe. And then there is the ultimate question, the possibility of life. If these hidden galaxies contain billions of stars, then they also contain billions of planets. And if we have underestimated the number of galaxies in the universe, then we have also underestimated the number of potentially habitable worlds. The search for extraterrestrial life has been limited to the galaxies we can see, but what if entire civilizations exist in galaxies that have remained hidden from us? Could there be advanced beings in one of these obscured galaxies, looking back at us while we are only just now beginning to see them? The discovery of hidden galaxies is a stark reminder that the universe is far from fully explored. It tells us that even in regions we thought we understood, there are still profound mysteries waiting to be uncovered. As we continue to push the boundaries of our knowledge, we must remain open to the possibility that the universe is far more complex and far more filled with unseen wonders than we ever imagined. The realization that entire galaxies have been hiding in plain sight forces us to rethink everything we thought we knew about the cosmos. And yet, for all the progress we have made, the greatest discoveries still lie ahead. The universe is an infinite puzzle, and every new revelation brings more questions. The more we uncover, the more we realize how little we truly know. Hidden galaxies are just one piece of this ever-expanding cosmic mystery, and as we develop new ways to peer beyond the dust, who knows what else we might find? Perhaps the greatest secrets of the universe are still waiting for us, just beyond the edge of our current understanding. The revelation of hidden galaxies behind the Milky Way's dust is not just a fascinating discovery, it's a fundamental shift in how we perceive the structure of the universe. For generations, astronomers have relied on visible light telescopes to map the cosmos, believing that the vast majority of galaxies were already accounted for. But now, we know that our view of the universe has been incomplete. The Milky Way itself has acted as a colossal cosmic curtain, blocking our ability to see what lies beyond it. These newly discovered galaxies force us to reconsider just how much of the universe remains hidden from view. One of the most remarkable aspects of these galaxies is how they have remained undetected for so long despite their sheer size. Some of them rival, or even exceed the Milky Way in mass and star formation. This suggests that our current models of galactic distribution may need revision. If hidden galaxies are this massive, then they likely contribute significantly to the gravitational web that shapes the large-scale structure of the universe. This could mean that our current estimates of galaxy clusters and cosmic filaments, those vast, thread-like structures that stretch across billions of light-years, are incomplete. The hidden galaxies may add new nodes to the cosmic web, subtly shifting our understanding of how galaxies are interconnected. But how exactly do these galaxies remain hidden? The answer lies in the nature of the zone of avoidance itself. The Milky Way is a spiral galaxy with a dense disk composed of stars, gas, and dust. This dust absorbs and scatters visible light, preventing us from seeing what lies behind it. However, different wavelengths of light behave differently. Infrared light, for example, has longer wavelengths that can pass through the dust more easily. This is why infrared telescopes like NASA's Spitzer Space Telescope and the European Space Agency's Herschel Space Observatory have been crucial in detecting these hidden structures. By looking in infrared rather than visible light, astronomers have been able to pierce through the cosmic fog and reveal the galaxies lurking behind it. Radio astronomy has also played a critical role in these discoveries. Radio waves, like infrared light, can penetrate the dense dust of the Milky Way. The use of radio telescopes has allowed astronomers to detect the hydrogen emissions from galaxies that were previously invisible. The Parkes Observatory in Australia, for example, has been instrumental in mapping out some of these hidden galaxies by detecting the faint radio signals emitted by their hydrogen gas. This method has revealed that the zone of avoidance is far from empty. It is teeming with galactic structures that have been hidden from us for millennia. One of the biggest questions now is how many more galaxies remain undiscovered. If we have only just begun to uncover these hidden structures, then it is possible that an enormous portion of the universe has yet to be mapped. Some astronomers estimate that there could be hundreds, if not thousands, of previously unknown galaxies behind the Milky Way. These galaxies could be harboring some of the most ancient and unusual stellar populations in existence. They could contain clues about the early formation of the universe, revealing conditions that have remained unchanged for billions of years. And then there's the mystery of the Great Attractor. The Great Attractor is an immense gravitational anomaly that appears to be pulling our galaxy, and many others, toward it at astonishing speeds. For decades, scientists have struggled to understand what lies at the heart of this pull. The problem? Much of the Great Attractor is hidden behind the zone of avoidance. Now, with the discovery of new galaxies in this region, we may finally be getting closer to understanding what is exerting this gravitational force. Some researchers believe that a supercluster of hidden galaxies could be responsible. If this is true, then our entire cosmic motion may be influenced by structures we have only just begun to uncover. But there's another, even more profound question: could these hidden galaxies contain planets with life? The search for extraterrestrial life has largely focused on the Milky Way and nearby galaxies like Andromeda and the Large Magellanic Cloud. But what if life exists in one of these hidden galaxies, completely unseen by us until now? The discovery of these galaxies expands the number of potential habitable worlds by an unknown factor. If each of these galaxies contains billions of stars, and each star has planets, then the number of possible Earth-like worlds just increased dramatically. This means that any estimates we have made about the probability of extraterrestrial life must now be re-evaluated. And what about intelligent life? Could there be civilizations in these hidden galaxies, looking back at us from behind the veil of cosmic dust? If advanced extraterrestrial beings exist in these galaxies, they may have been aware of us for much longer than we have been aware of them. After all, while our view of the cosmos has been blocked by dust, their perspective may be unobstructed. They may have had a clear view of the Milky Way and known about our existence long before we even realized they were there. This raises profound questions about the nature of first contact. If intelligent beings exist in one of these galaxies, how would they perceive us? Would they see us as an emerging civilization, or would they remain hidden, choosing to observe from afar? Even beyond the search for life, the implications of these hidden galaxies are staggering. If some of these galaxies are ancient and have remained relatively undisturbed, they may contain relics from the early universe, cosmic structures that formed in the first billion years after the Big Bang. Some may be home to the elusive population 3 stars, the first generation of stars that ever existed. These stars, if they still exist, would provide a direct window into the cosmic dawn. Discovering them would be like peering back in time to witness the birth of the universe itself. As telescopes like the James Webb Space Telescope and next-generation observatories come online, our ability to study these hidden galaxies will only improve. We are entering a new era of astronomy, one where the cosmic curtain of the Milky Way is being pulled back, revealing a universe far richer and more complex than we ever imagined. The hidden galaxies behind the Milky Way's dust are not just another scientific curiosity. They are a key to unlocking some of the deepest mysteries of the cosmos. And yet, the discoveries we have made so far may be just the tip of the iceberg. If the zone of avoidance has concealed so much from us, then what other cosmic blind spots exist? Could there be even larger hidden structures, entire clusters of galaxies, lurking just beyond our observational limits? Could there be regions of space so dense with dust and gas that entire portions of the universe remain obscured? If so, then our map of the cosmos is far from complete. This discovery forces us to confront an unsettling reality. We have only just begun to see the true scale of the universe. The galaxies we have catalogued so far may represent only a fraction of what actually exists. The cosmos is vaster and more mysterious than we ever dared to believe. Every new discovery raises more questions, and every hidden galaxy we uncover reminds us that the universe is still full of secrets waiting to be revealed. The idea that vast, hidden galaxies have been lurking just beyond our sight is not just a revelation, it's a humbling reminder of how little we truly understand about the universe. For decades, astronomers assumed that our view of the cosmos, though limited, was at least a relatively accurate representation of what was out there. But now, with the discovery of these obscured galaxies behind the Milky Way's thick veil of dust, we're realizing that our cosmic perspective has been incomplete. And if that's the case, how much of the universe remains unseen? How much more remains to be discovered? The zone of avoidance has acted as a natural barrier, preventing us from seeing what lies behind it. The thick clouds of interstellar dust in the plane of the Milky Way have absorbed visible light, making it impossible to see anything beyond a certain threshold. But thanks to infrared and radio astronomy, we are now able to cut through the dust and uncover structures that have remained hidden for billions of years. This has led to the shocking realization that there are massive galaxies, some even larger than the Milky Way, completely obscured from our view. These galaxies are not just isolated islands in space. They are part of the vast cosmic web, exerting gravitational influence, and shaping the large-scale structure of the universe in ways we are only beginning to understand. One of the most astonishing aspects of this discovery is the sheer scale of what we found. Some of these hidden galaxies contain hundreds of billions of stars, with star formation rates that rival or even exceed that of the Milky Way. This suggests that our models of galactic formation and evolution may need significant revision. If massive galaxies have been hiding behind the Milky Way this whole time, then we must ask, what else have we been missing? Are there even larger structures, perhaps entire superclusters, lurking just beyond our observational limits? And if so, how do these structures fit into our current understanding of cosmic evolution? Another crucial implication of these discoveries is the potential impact on dark matter studies. Dark matter is one of the biggest mysteries in modern astrophysics. It's an invisible substance that doesn't emit, absorb, or reflect light, yet it makes up the majority of the universe's mass. Scientists have been trying to map out where dark matter is concentrated by studying the distribution of galaxies and their gravitational effects. But if we've been missing a significant number of galaxies due to the zone of avoidance, then our dark matter maps might be incomplete. The hidden galaxies behind the Milky Way could be holding vast amounts of dark matter that we've never accounted for, meaning that our current models of the cosmic web could be skewed. The discovery of hidden galaxies also has major implications for the Great Attractor, one of the most perplexing gravitational anomalies in the universe. The Great Attractor is a mysterious region of space that appears to be pulling galaxies toward it with immense gravitational force. Our own Milky Way is moving toward it at a speed of around 600 kilometers per second, yet for decades, we had no idea what was causing this massive pull. The problem? Much of the Great Attractor is located in the zone of avoidance, hidden behind the Milky Way's dust. But now, with the ability to see through this cosmic barrier, astronomers have started to uncover entire clusters of hidden galaxies in this region. These newly discovered galaxies may hold the key to finally understanding what's causing the immense gravitational pull of the Great Attractor. If a massive supercluster of galaxies lies in this hidden zone, it could explain why so many galaxies, including our own, are being drawn toward it. But beyond the gravitational mysteries, there's also the tantalizing question of extraterrestrial life. The search for life beyond Earth has mostly focused on the Milky Way and a few nearby galaxies. But now, with the discovery of entire hidden galaxies, we must reconsider our assumptions. These galaxies contain billions of stars, and many of those stars likely have planetary systems. If life can emerge on Earth, then it stands to reason that it could also emerge on planets in these hidden galaxies. And if intelligent life exists in these galaxies, they may have had an unobstructed view of the Milky Way for billions of years. While we've only just discovered them, they may have been watching us all along. What if advanced civilizations exist in these hidden galaxies? And what if they have technology far beyond our own? If they've been aware of us for longer than we've been aware of them, it raises profound questions about the nature of contact. Would they ever attempt to reach out, or would they prefer to remain hidden? If they are capable of intergalactic travel, could they have already visited our galaxy without us even realizing it? These are questions that we may not be able to answer yet, but the very possibility makes the discovery of hidden galaxies even more profound. The realization that we've been missing entire galaxies also raises another unsettling possibility. Are there other cosmic blind spots that we haven't yet discovered? The Milky Way's dust has obscured an entire region of space from our view for centuries. But what if there are other regions of the universe that are similarly hidden? Could there be even more galaxies, or perhaps entire structures, that remain beyond our ability to detect? If so, then our current understanding of the universe is far from complete. As technology continues to advance, our ability to peer through cosmic dust and uncover hidden structures will only improve. The James Webb Space Telescope, with its powerful infrared capabilities, is expected to reveal even more of these hidden galaxies in unprecedented detail. Future radio telescopes, such as the Square Kilometre Array, will further refine our ability to detect faint radio emissions from obscured galaxies. These advancements mean that we are on the verge of an era where the zone of avoidance may no longer be a barrier at all. But the discoveries we've made so far are already enough to shake the foundations of astronomy. We now know that the universe is even larger and more complex than we once thought. The cosmic web is richer than we imagined, and the number of galaxies in the universe is likely far greater than we ever predicted. This forces us to reevaluate many of our assumptions about the cosmos. What else is out there, hiding in the shadows of space? Could there be undiscovered cosmic structures so vast that they change our entire perception of the universe? Could there be forces at work that we have yet to comprehend? The discovery of hidden galaxies behind the Milky Way's dust is just the beginning. It's a reminder that the universe is still full of secrets, waiting to be uncovered. The realization that we've been living in a cosmic blind spot for so long is both thrilling and humbling. For centuries, we assumed that our view of the universe, though vast, was at least a reasonable representation of what existed. But the discovery of hidden galaxies behind the Milky Way's dust forces us to admit that we've been missing an entire segment of the cosmos, one that could reshape our understanding of how galaxies form, interact, and evolve over billions of years. And this raises an even bigger question. If our own galaxy has been blocking such crucial information, how many other regions of the universe are similarly obscured? Could there be other massive structures, unknown forces, or even entire civilizations hidden behind cosmic veils that we simply haven't been able to penetrate yet? The idea that the zone of avoidance has concealed entire galaxies from us is not just a minor oversight, it's a fundamental gap in our cosmic knowledge. We now understand that some of the largest galaxies behind this veil could be interacting with our own galaxy in ways we haven't fully mapped. The gravitational pull of these hidden giants may be subtly influencing the motion of nearby galaxies, affecting galactic rotations and the structure of the cosmic web itself. This means that everything we thought we knew about how galaxies cluster and interact needs to be reconsidered in light of these discoveries. And let's not forget, the Milky Way is not a static object. It is constantly moving, rotating, and interacting with its cosmic environment. If there are massive galaxies lurking behind its dust clouds, their influence on the Milky Way might be greater than we ever anticipated. Could these hidden galaxies be slowly pulling at the Milky Way, affecting its trajectory across the universe? Could the combined gravitational effects of these galaxies be subtly shaping the entire structure of our local cosmic neighborhood? As we peel back the layers of dust using infrared and radio telescopes, we're beginning to uncover just how many galaxies we've been missing. Some of these galaxies are part of major superclusters, enormous cosmic structures that extend for hundreds of millions of light years. These superclusters contain thousands of galaxies, all connected through intricate networks of dark matter and intergalactic gas. The discovery of these hidden galaxies means that our understanding of the large-scale structure of the universe needs significant revision. If massive, unseen galactic structures are influencing cosmic expansion, then our models of dark matter, cosmic inflation, and even the fate of the universe itself may need to be updated. This also brings us to another crucial question. How did these galaxies form in the first place? The Milky Way's dust has hidden them from us, but they have been evolving in isolation for billions of years. Do they contain unique star formations? Do they follow the same rules of galactic evolution as the ones we've been studying? Or could these galaxies hold surprises, perhaps entirely new types of celestial phenomena that we have never encountered before? Some astronomers speculate that hidden galaxies might be home to some of the most extreme conditions in the universe. Because they've been isolated from much of the intergalactic radiation that reaches other galaxies, their star formation processes may be drastically different. Could these galaxies contain stars that are older, more massive, or fundamentally different from what we've observed? Could they hold exotic cosmic objects that we've never detected before? Perhaps stars made almost entirely of dark matter or planets that formed in conditions unlike anything we've ever seen? And then there's the question of black holes. Every major galaxy we've studied seems to contain a supermassive black hole at its core. If the hidden galaxies behind the Milky Way are truly as massive as we suspect, then they too must contain these monstrous objects. Some of these black holes might be among the largest in the universe, devouring entire stars and sending out gravitational waves that ripple across space-time. But because these galaxies have remained hidden for so long, we've never had a chance to study their black holes up close. Could these galaxies contain black holes that behave differently from the ones we know? Could they be more active, more powerful, or even more extreme than anything we've encountered? One of the most intriguing aspects of these hidden galaxies is their potential to reshape our search for extraterrestrial life. When we talk about the search for intelligent civilizations, we often focus on exoplanets within the Milky Way. But if there are entire galaxies that have remained hidden from our view, then the number of potentially habitable planets in the universe has just increased dramatically. Imagine an intelligent civilization that has developed in one of these hidden galaxies. They would have had an uninterrupted view of the cosmos for billions of years, free from the limitations imposed by the Milky Way's dust. If they had advanced astronomy, they may have mapped the entire universe long before we even realized they existed. From their perspective, our galaxy might be just another object in their cosmic observations, while we are only now discovering them. Could it be possible that extraterrestrial civilizations in these hidden galaxies have already been aware of us, watching us from a distance? And if so, would they ever try to contact us? But let's go even further. If these hidden galaxies contain advanced civilizations, they may have developed technologies beyond our comprehension. Perhaps they've already discovered ways to travel between galaxies, using methods that bypass the limitations of light-speed travel. If intergalactic civilizations exist in these hidden regions, their knowledge of the universe could be centuries or even millennia ahead of ours. What if they have already found solutions to some of the biggest cosmic mysteries, like the nature of dark matter, the true structure of space-time, or even the ultimate fate of the universe? The more we uncover about these hidden galaxies, the more we realize that our current understanding of the cosmos has been incomplete. We have been operating with only a partial map of the universe, missing entire sections that could contain crucial information about our origins, our cosmic environment, and even our future. The zone of avoidance was once thought to be just a minor observational inconvenience, but it turns out that it has been hiding some of the most significant cosmic structures in existence. And this is just the beginning. As we continue to refine our observational techniques, new telescopes will allow us to peer even deeper into these hidden regions. The James Webb Space Telescope, with its ability to detect infrared light, will give us an unprecedented view of the galaxies lurking behind the Milky Way's dust. Upcoming radio telescopes, like the Square Kilometre Array, will help us detect faint radio signals from these obscured galaxies, revealing details we never thought possible. We are entering an era where the concept of a hidden universe is no longer just science fiction, it is a reality. And if this is what we've been missing in just one small segment of the sky, then what else is waiting to be discovered? Are there even more zones of avoidance scattered across the universe? Could there be entire cosmic structures that have remained unseen, influencing the cosmos in ways we have yet to understand? The universe is a vast, mysterious place, and every new discovery reminds us of how much more there is to learn. The galaxies behind the Milky Way's dust are just one piece of the puzzle, but they are a piece that changes everything. The implications of discovering hidden galaxies behind the Milky Way's dust go beyond just filling in gaps in our cosmic map. They force us to rethink some of the most fundamental questions about the universe. If we have missed entire galaxies, what else have we overlooked? Could there be other cosmic structures, perhaps even entire superclusters or voids, hidden behind other obstructions across the sky? And if these galaxies have remained undetected for so long, how does that change our understanding of galactic evolution, dark matter distribution, and even the ultimate fate of the universe? One of the most pressing questions is, how many of these hidden galaxies are there? As of now, astronomers estimate that thousands of galaxies lurk behind the thick dust of the Milky Way, but that number could be much higher. Some of these galaxies are small dwarf galaxies, while others are massive and comparable to the Milky Way itself. But perhaps most intriguing are the giant elliptical galaxies and potential superclusters that may lie beyond our current reach. The discovery of the Vela supercluster, one of the largest known structures in the universe, was a groundbreaking moment, revealing just how much we were missing. If something that massive was hidden for so long, what else could be lurking in the darkness? The structure of the universe is shaped by the gravitational influence of galaxies, dark matter, and cosmic filaments. Until recently, our models of the universe were based on an incomplete picture. Now that we know entire clusters and superclusters were missing from our calculations, we have to ask, how does their presence change our understanding of cosmic evolution? The gravitational pull of these hidden galaxies likely affects the motion of the Milky Way itself. In fact, some astronomers believe that part of the reason our galaxy is moving in a certain direction could be due to the unseen mass behind it. If we have underestimated the number of galaxies in our local universe, then we have also underestimated the total mass influencing cosmic movements. This discovery also has significant implications for dark matter studies. Dark matter is one of the biggest mysteries in modern astrophysics. It's an invisible substance that makes up about 85% of the universe's total mass, yet we can't directly observe it. Scientists detect its presence by measuring the way galaxies move and interact. But if we've been missing thousands of galaxies, that means our calculations about dark matter distribution are incomplete. These hidden galaxies may hold the key to solving one of the greatest mysteries in physics. Could it be that the missing mass we attribute to dark matter is actually just normal matter hidden behind dust? Or could studying these galaxies help us refine our understanding of how dark matter interacts with regular matter? Another fascinating aspect of these hidden galaxies is the potential they hold for studying early cosmic history. Some of these galaxies formed billions of years ago, possibly among the first galaxies to take shape in the universe. Because of the thick dust blocking our view, they've remained largely untouched by previous observations. This means they could offer an unprecedented look at how galaxies formed in the early universe. By studying their structure, composition, and star formation history, we may gain new insights into the origins of the cosmos itself. And what about black holes? Every major galaxy we've studied has a supermassive black hole at its center. These objects shape the galaxies around them, controlling star formation, galactic mergers, and even the movement of cosmic gas. If the hidden galaxies behind the Milky Way contain supermassive black holes, and they almost certainly do, then we've been missing an entire population of these extreme objects. Some of these black holes could be larger and more active than anything we've observed. Others may be in the process of merging, producing gravitational waves that ripple across the universe. If we can detect and study these hidden black holes, it could change everything we know about how galaxies grow and evolve. And then there's the possibility of life. When we search for habitable planets, we usually focus on exoplanets within our own galaxy. But what if some of the hidden galaxies contain planets teeming with life? These galaxies have existed for billions of years, evolving in relative isolation behind the Milky Way's dust. If life developed in these galaxies, it would have followed a completely different evolutionary path from anything in our own galactic neighborhood. Could they have different forms of biology? Could they have developed civilizations that are far more advanced than anything we've imagined? And if so, have they been observing us while we remain blind to their existence? The more we uncover about these hidden galaxies, the more we realize how little we actually know. Our understanding of the universe has been limited by the simple fact that we can only see what's not blocked by cosmic obstacles. But with the advancement of infrared and radio telescopes, we are finally beginning to break through these barriers. The James Webb Space Telescope, for example, is allowing us to peer deeper into these obscured regions than ever before, revealing details we never thought possible. The Square Kilometer Array, an upcoming radio telescope network, will help us map out the structure of these hidden galaxies in unprecedented detail. We are on the brink of a new era in astronomy, one where the concept of a hidden universe is no longer just speculation, but a reality. And if this is what we've been missing in just one part of the sky, then what else could be out there? What other mysteries remain unseen, waiting for us to uncover them? The universe is vast, and every new discovery reminds us of how much more there is to learn. The galaxies hidden behind the Milky Way's dust are just the beginning of a larger truth. The cosmos is far more mysterious, complex, and surprising than we ever imagined. The idea that we have only just scratched the surface of what lies hidden behind the Milky Way's dust is both exhilarating and unsettling. For centuries, humans have looked up at the night sky, believing we had a fairly complete understanding of our cosmic neighborhood. But now, with the realization that thousands, possibly even millions, of galaxies have remained undetected just beyond our reach, the entire foundation of our understanding of the universe is shifting. This isn't just about discovering a few new celestial objects. It's about rewriting the very map of the cosmos, recognizing that we have been navigating with incomplete data all along. The implications of this discovery are staggering. The large-scale structure of the universe is built upon the distribution of galaxies, galaxy clusters, and dark matter. Astronomers have spent decades carefully mapping these structures, trying to understand the forces shaping the cosmos. But if we have been missing a significant portion of galaxies in our own vicinity, then our entire model of cosmic evolution may be incomplete. These hidden galaxies may account for a substantial amount of the gravitational forces affecting nearby galaxy movements, possibly explaining anomalies that have puzzled scientists for years. For instance, the Great Attractor, a mysterious gravitational anomaly pulling galaxies, including our own, toward it, has long been one of astronomy's greatest enigmas. Some scientists now believe that many of the hidden galaxies behind the Milky Way's dust contribute to this gravitational pull. These galaxies, previously invisible to us, may form part of an even larger supercluster whose gravitational influence extends across vast regions of space. If this is true, then our understanding of cosmic flows, how galaxies move and interact on the largest scales, needs serious revision. Another crucial aspect of this discovery is how it changes our approach to searching for habitable worlds. Traditionally, we've focused on exoplanets within the Milky Way, assuming that this was the most practical area to search for life. But what if some of the hidden galaxies contain planetary systems far different from our own? If these galaxies have been shielded from certain cosmic events due to their location behind the Milky Way, then they may have had unique conditions for life to emerge and evolve. Could there be civilizations in these galaxies that have been observing us, while we remained completely unaware of their existence? Could some of the signals we've detected from deep space, like the famous "wow" signal, have originated from one of these hidden galaxies, previously mistaken for empty space? And then there's the question of cosmic dust itself. The very substance that has concealed these galaxies is also a crucial building block for planets, stars, and life. Interstellar dust contains complex organic molecules, some of which are the precursors to life as we know it. Understanding the properties of this dust, its origins, and how it affects observations could help us not only detect more hidden galaxies but also uncover new insights into how life may have begun in the universe. If certain types of dust are more effective at blocking visible light than others, then there could be even more hidden regions of the sky where entire galactic structures remain undetected. The advancement of telescope technology is playing a pivotal role in this unfolding mystery. Infrared and radio telescopes have already revealed some of these hidden galaxies, but future missions will take this research even further. The Square Kilometer Array, once fully operational, will provide the most detailed radio observations ever recorded, allowing us to peer deeper into the cosmic veil. The Vera C. Rubin Observatory, with its powerful survey capabilities, will also help map out structures that have remained elusive for decades. Meanwhile, the James Webb Space Telescope continues to push the boundaries of what we can see, capturing light from the most obscured regions of the universe. But what if even these advanced tools are still missing something? If the Milky Way's dust has hidden so much already, then it's possible that other galaxies have similar obstructions preventing us from seeing what lies beyond them. Could there be even larger structures, vast cosmic entities spanning billions of light years, hidden behind other galaxies just as these ones were hidden behind the Milky Way? And if so, what does that mean for our understanding of the universe's true scale? These discoveries also have profound implications for the search for dark matter. For decades, astronomers have tried to account for the missing mass of the universe, matter that we can't see, but whose gravitational effects we can detect. Many believe this missing mass is made up of dark matter, an unknown form of matter that does not emit, absorb, or reflect light. However, if thousands of galaxies were hiding right in front of us, it raises the question, how much of what we call dark matter is actually just normal matter that we've been unable to detect? If more hidden galaxies are uncovered, we may need to revise our estimates of dark matter's contribution to the universe's total mass. Even more fascinating is the possibility that these galaxies contain new types of astronomical phenomena that we have never observed before. Every time we discover a new class of galaxies, we find surprises. Whether it's galaxies without dark matter, galaxies with ultra-high star formation rates, or galaxies behaving in ways that defy our current models. The hidden galaxies behind the Milky Way may include objects that challenge everything we think we know about galaxy formation and evolution. What if some of these galaxies form differently due to their isolated position? What if they contain rare or unknown types of stars, black holes, or even exotic forms of matter? One thing is certain, this discovery is only the beginning. The more we explore the hidden universe, the more we realize how much has been beyond our reach. If entire galaxies and possibly superclusters have remained hidden in one part of the sky, then there's no telling what else is waiting to be uncovered in other obscured regions. With every new breakthrough, we are rewriting our cosmic story, filling in missing pages of a book we once thought we had already read. And so, the next time you look up at the night sky, remember this: what you see is only a fraction of what's really out there. Beyond the glowing stars, past the faint nebulae, behind the Milky Way's dust, lies a hidden universe, one that is only now beginning to reveal its secrets. If we've learned anything from the discovery of these hidden galaxies, it's that the universe has been keeping secrets from us, and we've only just begun to unravel them. The existence of these obscured galaxies forces us to rethink our understanding of cosmic structures and the forces shaping the universe. It's as if we've been reading a book with missing pages, and now, for the first time, we're beginning to glimpse what's truly written in the margins of the cosmos. But this revelation also raises even deeper questions. If these galaxies have remained hidden from us for so long, then how many other objects, perhaps even more extraordinary than we can imagine, are still concealed behind cosmic veils? Could there be entire regions of the universe filled with strange, unseen phenomena that defy our current understanding of physics? Could there be new types of celestial bodies, exotic forms of matter, or even structures so massive that they bend and warp spacetime in ways we've never observed before? One of the most intriguing aspects of this discovery is the role that galactic dust has played in keeping these galaxies hidden. While dust is often seen as an obstacle for astronomers, blocking light and obscuring our view, it is also one of the fundamental ingredients of the universe. Without interstellar dust, planets wouldn't form, stars wouldn't have the materials they need to create solar systems, and life as we know it wouldn't exist. Yet, despite its importance, we still don't fully understand the properties of this dust, where it comes from, or how it evolves over time. The dust that obscures these hidden galaxies is made up of tiny particles, often smaller than a grain of sand, composed of carbon, silicon, and other elements forged in the hearts of dying stars. These particles absorb and scatter visible light, making it impossible to see what lies beyond them with optical telescopes. However, when viewed in infrared or radio wavelengths, the universe begins to reveal its hidden secrets. The fact that we have only recently been able to detect these galaxies shows how much our technological advancements are expanding our view of the cosmos. And this is just the beginning. As more powerful telescopes come online, such as the Square Kilometre Array and next-generation space observatories, we will be able to penetrate even deeper into the hidden universe. There may be entire clusters of galaxies waiting to be discovered, each containing billions of stars and potentially untold numbers of planets. What if some of these galaxies have been shielded from cosmic radiation, allowing for entirely different evolutionary paths for planets and potential lifeforms? What if civilizations exist in these galaxies that have never detected us, just as we have never detected them? This discovery also forces us to reconsider how we perceive the structure of the universe itself. If so many galaxies have remained hidden behind the Milky Way, then it's possible that similar obstructions exist elsewhere in the cosmos. Could there be vast superclusters lurking in other parts of the sky, their light blocked by other galactic structures? Could the distribution of galaxies we've mapped so far be incomplete, misleading us about the true nature of cosmic expansion and the large-scale structure of the universe? Another fascinating implication is how these hidden galaxies could impact our understanding of dark matter. For decades, astronomers have been searching for an explanation for the universe's missing mass, an invisible substance believed to make up most of the universe's total mass. But if thousands of galaxies have been hiding in plain sight, then the mass estimates we've been relying on may need serious revision. Could it be that a portion of what we've attributed to dark matter is actually just normal matter that was previously undetectable? Could these hidden galaxies provide clues that help us finally understand the true nature of dark matter, or even reveal an alternative explanation for its existence? And then there's the question of cosmic history. The universe is not static. It has been evolving for billions of years, shaped by gravitational interactions, cosmic collisions, and the relentless expansion of space itself. If these hidden galaxies have been isolated from many of the interactions that shaped more visible galaxies, they could offer a unique glimpse into the past. Some of them may have remained relatively unchanged for billions of years, preserving information about the early universe that would otherwise be lost. Others may have undergone completely different evolutionary paths, shaped by forces we have yet to understand. Even the idea of galactic collisions takes on a new meaning when considering these hidden galaxies. Throughout cosmic history, galaxies have merged, collided, and reshaped each other in dramatic ways. But if there are thousands of galaxies hidden behind the Milky Way, then it's possible that some of these galaxies have undergone interactions we've never observed before. Could there be massive galactic collisions happening just beyond our view? Could there be entire star-forming regions hidden within these galaxies, creating new generations of stars in ways we've never seen? And what about black holes? Every large galaxy we know of contains a supermassive black hole at its center, warping space and time around it. If thousands of hidden galaxies exist, then there must also be thousands of hidden supermassive black holes. Some of them may be actively feeding on surrounding matter, releasing powerful jets of energy that remain undetected due to the dust blocking their light. Others may be dormant, waiting for new material to fall into their grasp. Could some of these hidden black holes be influencing the motion of nearby galaxies without us realizing it? Could they be part of the explanation for the mysterious gravitational anomalies we've observed in the cosmic neighborhood? There is so much more to explore, so many unanswered questions that are now more pressing than ever. What if the largest structure in the known universe, larger than anything we've ever detected, is hidden behind the Milky Way's dust, stretching across vast cosmic distances? What if there are patterns in the arrangement of these galaxies that reveal something fundamental about the nature of spacetime itself? What if some of these galaxies contain cosmic phenomena so bizarre that they challenge the very foundations of physics? One thing is certain, the universe has been keeping secrets from us, and we are only now beginning to uncover them. With every new discovery, we are reminded of how much we still don't know. The cosmos is vast, mysterious, and full of surprises, and as we continue to push the boundaries of our knowledge, we will undoubtedly find even more hidden truths waiting to be revealed. The idea that entire galaxies, each containing billions of stars, planets, and cosmic structures, have been hidden just beyond our view is both thrilling and humbling. It forces us to confront the fact that our perception of the universe has always been incomplete. For centuries, astronomers have mapped the stars and traced the outlines of galaxies, believing they were seeing the full picture. But now, as our technology advances and we develop new ways to pierce through cosmic obstructions, we're beginning to realize just how much of the cosmos has remained hidden from us. One of the most astonishing implications of these hidden galaxies is that they may completely reshape our understanding of galactic formation and evolution. Astronomers have long believed that galaxies follow a somewhat predictable life cycle, forming from the gravitational collapse of gas clouds, growing as they consume more material, and sometimes merging with other galaxies to become even larger. But what if these hidden galaxies have evolved differently? Could some of them have formed in ways that challenge our current models? Could they be home to structures or cosmic phenomena that are absent in the more visible parts of the universe? This discovery also raises major questions about the true size and shape of the Milky Way itself. If we have been unable to see these galaxies because they are hidden behind our own, then it's possible that our understanding of the Milky Way's outer reaches is also incomplete. There could be entire sections of our galaxy that we have yet to fully explore, possibly containing unexpected structures such as previously unknown star clusters, extended spiral arms, or even smaller satellite galaxies that have remained unseen until now. The gravitational interactions between the Milky Way and these hidden galaxies may also be more significant than we realize, subtly influencing the motion of stars and gas within our galaxy in ways we have yet to fully comprehend. Another mind-bending possibility is that these hidden galaxies could harbor some of the most ancient and pristine environments in the cosmos. If they have remained isolated from major cosmic events such as galactic collisions or large-scale gravitational disruptions, then they might preserve conditions that are similar to those that existed in the early universe. This means that studying them could give us an unprecedented glimpse into what the universe looked like billions of years ago, providing a kind of cosmic time capsule that could help answer some of the biggest questions in astrophysics. And then, of course, there is the question of life. If we have been unable to see these galaxies, then it stands to reason that any civilizations within them have also been unable to see us. Could intelligent life be evolving in these hidden galaxies, completely unaware of our existence, just as we were unaware of theirs until now? Could this discovery change our entire approach to the search for extraterrestrial intelligence? If these galaxies have been shielded from high-energy cosmic radiation in ways that other galaxies have not, then could they provide a more stable environment for life to thrive? Beyond just the possibility of life, these galaxies could contain some of the rarest and most exotic cosmic phenomena. We already know that different galaxies produce vastly different types of stars, planetary systems, and nebulae, depending on factors such as their chemical composition and rate of star formation. If these hidden galaxies have been evolving in isolation, then they might contain celestial objects that don't exist anywhere else in the known universe. Could they harbor new types of stars, unlike anything we've ever seen? Could they contain planets made of materials that are rare or even non-existent in our part of the cosmos? Could they be home to cosmic structures that defy our understanding of astrophysics? The sheer scale of what we have yet to uncover is staggering. For every galaxy we can see, there may be countless more that remain obscured, waiting to be found. As we continue to improve our observational techniques, we are likely to uncover even more hidden galaxies, not just behind the Milky Way's dust, but in other areas where cosmic obstructions have kept them out of sight. Each new discovery will bring with it more mysteries, more questions, and more opportunities to redefine what we know about the universe. And yet, this is only the beginning. The more we learn about these hidden galaxies, the more we will realize just how much we still don't know. This discovery is not just about revealing what has been hidden, it's about opening the door to an entirely new way of looking at the cosmos. What other cosmic secrets are still waiting to be uncovered? What new questions will arise as we begin to study these galaxies in detail? And most importantly, how will this change our place in the universe? The realization that entire galaxies have been hiding behind the Milky Way's dust is more than just a remarkable discovery. It's a wake-up call. For decades, astronomers have believed that their telescopes, no matter how powerful, were showing them the grand picture of the universe. But now, we're starting to see that this picture was incomplete all along. If such massive structures, entire galaxies, with billions of stars and possibly trillions of planets, could remain hidden just beyond our sight, then what else might be lurking out there, still undiscovered? This isn't just about astronomy. It's about the limits of human perception and the vast unknowns that still surround us. The biggest challenge with uncovering these hidden galaxies has always been the thick, choking veil of interstellar dust that blocks visible light. This dust, made up of microscopic grains of carbon and silicate materials, is spread throughout the Milky Way in enormous clouds. It absorbs and scatters light from stars and galaxies behind it, making them almost impossible to see with traditional optical telescopes. For a long time, this was an unsolvable problem. No matter how powerful our telescopes became, they simply couldn't look through the dust. It was like trying to see a distant lighthouse through an impenetrable fog. But recent technological advances have changed the game. Infrared telescopes, such as NASA's Spitzer Space Telescope and the European Space Agency's Herschel Space Observatory, have given astronomers a new way to peer through the cosmic fog. Unlike visible light, which gets blocked by dust, infrared light can pass through it. This means that objects that were once invisible to us are now beginning to emerge from the shadows. And what we're finding is beyond anything we expected. One of the most astonishing discoveries came when astronomers used infrared and radio telescopes to scan a region of the sky known as the zone of avoidance. This is an area where the Milky Way's dense dust clouds have historically prevented us from seeing what lies beyond. But when researchers looked at this region using infrared and radio wavelengths, they found something stunning: entire galaxies, stretching across vast distances, completely hidden from view until now. Some of these galaxies are among the largest and most massive we've ever discovered, containing trillions of stars and spanning hundreds of thousands of light-years. One such discovery was the Vela supercluster, a massive collection of galaxies that had been hiding behind the Milky Way's disk. This supercluster, located roughly 800 million light-years away, is one of the largest structures in the known universe. It contains thousands of galaxies, each with billions of stars, and its gravitational influence extends across enormous distances. Before its discovery, astronomers had been puzzled by certain unexplained gravitational anomalies in this region of space. Now, we know that the Vela supercluster was the missing piece of the puzzle, an enormous hidden mass that had been warping the motion of galaxies across the cosmos. But the implications of these hidden galaxies go far beyond just their size and number. They challenge our very understanding of cosmic structures and how galaxies interact with one another. The Milky Way itself is part of a larger structure known as the Laniakea supercluster, a vast network of galaxies bound together by gravity. If we're now discovering hidden galaxies in our cosmic backyard, then it's possible that even our understanding of Laniakea is incomplete. There could be even larger, more complex structures lurking just beyond our current observational limits, waiting to be uncovered. And then there's the question of dark matter. One of the biggest mysteries in modern physics is the nature of dark matter, the invisible substance that makes up about 85% of the universe's total mass. Scientists know dark matter exists because of its gravitational effects, but they've never been able to observe it directly. The discovery of these hidden galaxies could provide new clues about where dark matter is concentrated and how it shapes the universe on the largest scales. If some of these galaxies are rich in dark matter, they could serve as natural laboratories for studying this elusive force and finally unraveling one of the biggest mysteries in astrophysics. But perhaps the most exciting possibility is that these newly discovered galaxies could change the way we think about cosmic evolution. The standard model of galaxy formation suggests that galaxies grow over time through mergers and interactions with other galaxies. But if entire galaxies have remained hidden behind the Milky Way for billions of years, relatively undisturbed, then they might offer a unique window into what the universe looked like in its early stages. These galaxies could contain ancient stars that formed in the first billion years after the Big Bang, providing critical insights into the birth of the cosmos. And let's not forget the search for life. If these galaxies have been isolated from much of the high-energy radiation and galactic collisions that have shaped the more visible parts of the universe, then they might offer stable environments where life could develop and thrive. What if there are planets in these galaxies that have been orbiting their stars in perfect conditions for billions of years? What if intelligent civilizations have evolved there, completely cut off from the rest of the universe? The idea that alien life could exist in these hidden realms, just beyond our reach, is one of the most thrilling aspects of this discovery. The more we uncover about these hidden galaxies, the more we realize that our understanding of the universe is still in its infancy. Just a few decades ago, astronomers believed that the observable universe was essentially all there was. Now, we're beginning to see that entire galactic superstructures have remained undetected, right in our own cosmic neighborhood. This isn't just a minor correction to our cosmic maps, it's a complete revolution in how we see the universe. And yet, this is only the beginning. As new telescopes come online, such as the James Webb Space Telescope, which has unprecedented infrared capabilities, we're likely to uncover even more hidden galaxies, in even greater detail. The discoveries we've made so far are just the first cracks in the cosmic veil. As we continue to push the limits of our technology, we may soon find that the universe is far larger, more complex, and more mysterious than we ever imagined. What else is hiding in the darkness, waiting to be revealed? What other secrets are concealed behind the cosmic dust, beyond our current field of view? And how will these discoveries change the way we think about our place in the vast, ever-expanding cosmos? The idea that entire galaxies have remained hidden behind the Milky Way's dust for billions of years is a humbling reminder of how little we truly know about the universe. For all the powerful telescopes, deep space probes, and sophisticated simulations we've developed, the cosmic landscape is still full of secrets. The very notion that such immense structures, galaxies containing trillions of stars, potentially untold numbers of planets, and possibly even unknown forms of life, have been lurking just beyond our sight should make us question the completeness of our understanding. If something as enormous as a supercluster can be hidden in plain sight, then what else might we be missing? One of the most fascinating aspects of these hidden galaxies is how they might redefine our cosmic address. We often think of the Milky Way as a massive, dominant galaxy within the local universe. But if we're just now discovering entire clusters of galaxies in our immediate vicinity, then we might not be as isolated or as central as we once believed. Our entire cosmic map, our understanding of which galaxies are near and how they interact, could be significantly outdated. We may be living in a far more interconnected and dynamic region of space than we ever imagined. Take, for example, the newly discovered galaxies in the zone of avoidance. Before astronomers peered into this region using infrared and radio telescopes, they had no idea how many hidden objects were lurking there. Some of these galaxies appear to be massive spiral galaxies, similar in size or even larger than the Milky Way. Others are dense elliptical galaxies, packed with old stars that have been burning for billions of years. But the most intriguing discoveries are the galaxies that seem completely different from anything we've seen before. Galaxies that appear distorted, stretched, or shaped in ways that defy our current understanding of galactic formation. Could these be the remnants of ancient collisions? Or are they evidence of new types of galactic structures we've never encountered? The discovery of the Vela supercluster was a major breakthrough, but what's even more mind-blowing is that this could be just one of many hidden superclusters. If Vela was lurking behind the Milky Way undetected for so long, then how many more might be out there, waiting to be found? The more we uncover, the more it seems that our entire concept of large-scale cosmic structure is incomplete. These hidden superclusters could play a significant role in the way galaxies move and interact across billions of light years. They could explain certain gravitational anomalies that astronomers have observed, subtle tugs and accelerations that don't seem to match the known distribution of matter in the universe. This brings us to another major question: how do these hidden galaxies fit into the dark matter puzzle? Scientists know that dark matter plays a crucial role in shaping the cosmos, acting as an invisible scaffold that holds galaxies together. But they still don't fully understand how it's distributed. If some of these newly discovered galaxies contain significant amounts of dark matter, then they might help astronomers finally map out its true distribution. This could provide key insights into what dark matter actually is, whether it's made of weakly interacting particles, whether it forms vast cosmic filaments, or whether our entire understanding of gravity itself needs to be re-examined. And what about the role of black holes in these hidden galaxies? Every large galaxy we've studied so far appears to have a supermassive black hole at its core, an immense, gravitationally powerful object that shapes the galaxy's evolution. If these newly discovered galaxies also contain supermassive black holes, then they could provide valuable clues about how black holes grow over time, and how they influence the development of their host galaxies. Some of these hidden galaxies might even contain some of the largest black holes in the universe, monsters that have been feeding in the dark for billions of years, completely unnoticed until now. But perhaps the most tantalizing possibility of all is the potential for life. If these galaxies have been shielded from some of the more violent cosmic events that have shaped the visible universe, like intense gamma-ray bursts, supernova explosions, and intergalactic collisions, then they might provide stable environments where life could thrive. Could there be planets in these galaxies that have remained untouched by cosmic upheaval for billions of years, giving life an uninterrupted chance to evolve? Could there be intelligent civilizations in these hidden galaxies, looking out at their own sky, completely unaware that we exist just beyond the cosmic dust? This discovery also raises questions about our own future. If entire galaxies can remain hidden from us for so long, then it means our observational methods still have significant limitations. Even with the most powerful telescopes, we're still only seeing a fraction of what's actually out there. But as technology advances, new telescopes like the James Webb Space Telescope and future generations of space-based observatories could reveal even more. The more we refine our ability to see through cosmic dust, the more we'll uncover, and each discovery will bring with it new mysteries, new questions, and new possibilities. For now, what we do know is this: the universe is far more complex, far more intricate, and far more mysterious than we ever thought possible. The galaxies we've already discovered behind the Milky Way's dust are just the beginning. There are likely many more waiting to be found, many more cosmic secrets hiding just out of reach. And as we continue to push the boundaries of exploration, we might just find that the universe we thought we knew is only a tiny glimpse of the true vastness of existence. The realization that we have only just begun to uncover these hidden galaxies forces us to reconsider our understanding of the local universe. For centuries, we have mapped the night sky, cataloging every visible galaxy, nebula, and cluster we could detect with the technology at hand. But what if our cosmic map is missing an enormous portion of reality? The zone of avoidance, which was once considered an observational dead zone, is now proving to be a treasure trove of new discoveries. And this raises an unsettling question: how much of the universe is still hidden from us? The implications of these hidden galaxies extend beyond mere cartography. If we have misjudged the number, distribution, and mass of galaxies in our immediate cosmic neighborhood, then this miscalculation could have profound effects on our understanding of galactic evolution, gravitational interactions, and even the expansion of the universe itself. We rely on precise measurements of visible matter to refine our models of the cosmos. But if an entire hidden framework of galaxies exists behind the Milky Way's dust, then our calculations might need major revisions. Could the influence of these unseen galaxies explain some of the anomalies we've observed in the motion of nearby galaxy clusters? Could they be exerting gravitational forces that we've attributed to dark matter, or could they be affecting the cosmic web in ways we haven't yet understood? One of the most striking aspects of these discoveries is the sheer scale of the structures we are finding. The Vela supercluster, for example, is an immense concentration of galaxies stretching across hundreds of millions of light-years. Yet, for most of human history, it remained completely unknown to us. The fact that such a massive structure was hiding just beyond the veil of the Milky Way's dust suggests that there may be even larger, even more mind-boggling cosmic structures still awaiting discovery. Could there be entire galactic superstructures, walls, filaments, and voids hiding behind our own galaxy, waiting for advanced telescopes to unveil them? Another key question revolves around the age and composition of these hidden galaxies. Since they have been obscured for billions of years, they might hold clues about an earlier era of cosmic history, untouched by the same environmental factors that shaped more visible galaxies. Some of these hidden galaxies might be relics of the early universe, preserving ancient star populations that could help us understand how the first galaxies formed. Others might have developed in relative isolation, forming unique structures and star types that don't match anything we've seen before. If we could analyze their chemical compositions, we might even uncover new insights into the life cycles of galaxies, the processes of star formation, and the origins of heavy elements in the cosmos. There's also the possibility that some of these galaxies contain exotic forms of matter or energy. Given that we are still struggling to fully understand dark matter and dark energy, the discovery of a large, previously unknown population of galaxies could offer new data that either confirms or challenges our current models. If some of these galaxies behave differently than expected, perhaps exhibiting unusual rotation curves, unexpected levels of radiation, or strange distributions of mass, then they could provide new clues about the fundamental forces that govern the universe. Could some of these galaxies be dominated by dark matter to an extreme degree, making them almost invisible except for their gravitational effects? Could they host unusual forms of stellar remnants, like ultramassive neutron stars or exotic white dwarfs? And what about the possibility of hidden quasars? Quasars are the extremely bright, energetic centers of galaxies powered by supermassive black holes that are actively consuming surrounding matter. In the visible universe, we have detected thousands of quasars, some of which shine with the intensity of trillions of stars combined. But what if some of the brightest quasars in the universe have been lurking behind the Milky Way's dust, invisible to traditional optical telescopes? If we start detecting hidden quasars using infrared and radio astronomy, it could dramatically reshape our understanding of black hole activity across cosmic time. The more we uncover, the more it becomes clear that these hidden galaxies are not just a minor footnote in astronomy. They are a major missing piece of the puzzle. Every discovery adds to the growing realization that our view of the universe has been significantly incomplete. But with each new technological advancement, we are slowly peeling back the veil, revealing a far more complex and dynamic cosmos than we ever imagined. Perhaps the most poetic aspect of this discovery is the idea that the universe is still full of secrets, waiting to be uncovered. We like to believe that we live in an age of scientific enlightenment, where the major mysteries have already been solved. But the reality is that we are still in the infancy of cosmic exploration. The hidden galaxies behind the Milky Way's dust are just one example of how much remains unknown. If something as massive as an entire supercluster can remain undetected for so long, then what else might be out there? Could there be even more obscured regions of space, filled with structures we have yet to imagine? Could there be entire populations of unseen stars, planets, and cosmic phenomena waiting for us to develop the right tools to find them? As we continue to refine our methods of observation, we may one day reach a point where the entire sky is laid bare, where no dust cloud, no cosmic obstruction, and no limitation of human technology can prevent us from seeing the full expanse of the universe. When that day comes, we may look back at this era as one of blindness, a time when we were still learning how to truly see. But for now, every new discovery, every hidden galaxy revealed, is a step closer to understanding the true nature of the cosmos. The more we uncover about these hidden galaxies, the clearer it becomes that our understanding of the universe has been limited not just by technology, but by the fundamental constraints of our vantage point. The Milky Way is not just a home, it is a massive, complex structure that acts as both an anchor and an obstruction. For centuries, our observations were confined to what could be seen with the naked eye, and even with the most advanced telescopes, the thick clouds of gas, dust, and interstellar debris have masked an entire section of the cosmos. But now, as infrared and radio technology improve, we are beginning to break through this veil, and what we are finding is nothing short of staggering. These hidden galaxies are more than just a collection of stars and matter, they represent a fundamental piece of the cosmic puzzle. Imagine if, for centuries, we had been trying to understand Earth's geography but were unable to see an entire continent. That's essentially what has been happening with our galactic maps. The zone of avoidance has long been a blind spot, and now that we are uncovering its secrets, we are realizing that the universe is far more vast, intricate, and interconnected than we ever assumed. But what does this mean for the big picture? One of the most important implications of discovering hidden galaxies is the effect they have on our understanding of cosmic structure. The universe is not just a random scattering of galaxies. It is a vast, interconnected web, where gravity, dark matter, and the fundamental forces of nature shape everything from the smallest clusters to the largest superstructures. If there are entire galaxies and even superclusters hiding behind the Milky Way, then our calculations about the density of the universe, the distribution of mass, and even the expansion rate of the cosmos may need to be revised. For example, one of the key principles in modern cosmology is the large-scale structure of the universe, which follows a pattern of filaments, voids, and clusters. These structures formed over billions of years as matter clumped together due to gravitational attraction. But if we have been missing entire sections of this cosmic web, then we may be underestimating the total mass of the universe in our region of space. This could, in turn, impact our understanding of dark matter, which is inferred based on gravitational effects. Could some of the gravitational anomalies we've observed be explained by these hidden galaxies? Could their mass be subtly pulling on visible structures, influencing their motion in ways we never accounted for? Then there is the question of cosmic evolution. If these galaxies have remained hidden for so long, they may have evolved differently from those we typically observe. Most of our understanding of galaxy formation comes from objects that are visible in optical wavelengths, meaning they are either unobscured or relatively nearby. But galaxies that have been shrouded in dust may have experienced different conditions, with unique rates of star formation, different interactions with their environments, or even alternative compositions. Studying these galaxies could give us a more complete picture of how the universe has evolved over billions of years, and it could challenge some of our fundamental assumptions about galactic life cycles. One of the most exciting prospects of this research is the potential discovery of new, extreme astrophysical phenomena. Could these hidden galaxies contain an unusually high number of black holes? Could they harbor exotic forms of matter or energy that we have never encountered? Could they be home to ancient stellar populations that provide insight into the early universe? If some of these galaxies formed in isolation, free from the typical gravitational influences of more well-known galactic clusters, they could serve as natural laboratories for testing theories about cosmic evolution. There is also the question of what role these galaxies might play in the future. The universe is constantly changing, with galaxies moving, merging, and interacting on timescales spanning billions of years. If some of these hidden galaxies are closer than we think, could they one day collide with the Milky Way? Could they be part of an unseen gravitational dance that will eventually bring them into contact with our own galaxy? Understanding their motion and trajectories is crucial, as it could help us predict the long-term fate of the Milky Way and its cosmic neighborhood. And of course, there is the lingering question of whether these galaxies could harbor planets, and possibly life. If they have been hidden from our view, then any exoplanets within them would have been equally obscured. This means that entire planetary systems could exist in these hidden galaxies, with conditions that we have never considered before. Could there be worlds in these galaxies that have remained undetected for all of human history? Could there be civilizations that have developed in total obscurity, never knowing that the rest of the universe exists beyond their cosmic dust veil? These are not just hypothetical questions, they are the kinds of mysteries that push the boundaries of what we know and drive scientists to develop new technologies, new observational techniques, and new theories. The more we discover, the more we realize how little we truly understand. The hidden galaxies behind the Milky Way's dust are not just another discovery. They are a reminder that the universe is far more complex, more mysterious, and more breathtaking than we could have ever imagined. As we continue to refine our observations and uncover more of these hidden structures, we may find that our picture of the universe is radically different from what we thought. The galaxies we have mapped so far might be only a fraction of what truly exists, and the forces shaping our cosmos might be far more intricate than we assumed. The future of astronomy will undoubtedly involve breaking through more of these cosmic barriers, revealing more of the unseen, and slowly bringing the entire universe into focus. And yet, even as we uncover more and more, one thing remains certain: there will always be more mysteries waiting beyond the next discovery. The hidden galaxies behind the Milky Way's dust are just the beginning. As we peer deeper into the hidden regions of the cosmos, we begin to realize just how much of our understanding has been shaped by the limitations of our own vantage point. The fact that entire galaxies have remained unseen for so long raises an unsettling yet exhilarating question: how much of the universe have we yet to even glimpse? The Milky Way's dense core and dust clouds have acted like cosmic blindfolds, keeping us in the dark about entire galactic structures that could rewrite our understanding of cosmic formation, gravitational interactions, and even the fate of our own galaxy. But with the advent of more powerful observational tools, we are finally beginning to lift that veil. And what we are finding is astonishing. One of the most mind-bending revelations of these hidden galaxies is their sheer number. Scientists once assumed that the region obscured by the Milky Way, known as the zone of avoidance, might contain only a handful of galaxies, similar to those found in more visible parts of the sky. But new surveys using radio and infrared telescopes have revealed a completely different reality. This region is not just dotted with galaxies, it is teeming with them. Some estimates suggest that thousands of previously unknown galaxies exist behind the Milky Way, some of which may be part of massive, undiscovered superclusters. The implications of this are staggering. For starters, our understanding of the distribution of matter in the universe is based on what we can see. But if entire galactic structures have been hidden from view, then our models of the large-scale universe are incomplete. The hidden mass in these galaxies could influence everything from cosmic expansion rates to the mysterious force of dark matter. If some of the unexplained gravitational anomalies observed in the cosmos are being caused by these obscured galaxies, then our entire framework for understanding cosmic motion may need to be re-evaluated. Even more fascinating is the question of how these galaxies evolved in near total isolation from our observations. We have long believed that galaxies form and develop in relatively predictable ways, through star formation, interactions, mergers, and the gradual influence of gravity. But what if the galaxies hidden behind the Milky Way have followed an entirely different evolutionary path? What if their isolation has led to unique forms of stellar evolution, exotic compositions, or even unusual cosmic phenomena that we have never encountered before? One particularly intriguing discovery is the presence of ultramassive galaxies lurking behind the Milky Way. Some of these galaxies are thought to be larger than the Andromeda Galaxy, containing trillions of stars and vast networks of gas and dust. If such colossal structures have remained hidden until now, then our assumptions about the largest galactic formations in the universe may need to be adjusted. These massive galaxies could hold secrets about the earliest periods of galaxy formation, shedding light on how matter coalesced in the young universe and how galaxies reached such enormous scales. The discovery of hidden galaxies also has profound implications for our understanding of galactic motion. The gravitational pull of these unseen galaxies may be subtly influencing the movement of the Milky Way itself. If these galaxies are part of a much larger supercluster, then the entire region of space we occupy could be shaped by forces we have only just begun to uncover. Could our own galaxy be on a long-term collision course with some of these hidden giants? Could their gravitational influence be responsible for some of the anomalies in the motion of nearby galaxies? These are questions that scientists are now beginning to explore with fresh urgency. And then there is the question of exoplanets. If these galaxies are home to billions or even trillions of stars, then they are almost certainly home to an untold number of planetary systems as well. The search for extraterrestrial life has largely focused on planets within our own galaxy, particularly those within the habitable zone of their parent stars. But what if entirely new types of planetary environments exist within these hidden galaxies? What if life has emerged in ways we have never imagined, in conditions completely different from those we have studied? Some scientists have speculated that certain types of life-bearing planets might exist in more extreme galactic environments, perhaps within the dense centers of massive, dust-shrouded galaxies. If these hidden galaxies contain ancient, stable planetary systems, they could provide a unique opportunity to study the long-term potential for life beyond Earth. Could civilizations exist within these galaxies, completely unaware of the rest of the universe due to the thick layers of cosmic dust that enshroud them? The idea is as haunting as it is fascinating. The technological advances that have allowed us to uncover these hidden galaxies are only the beginning. As observational tools continue to improve, we will gain an even clearer picture of what lies beyond the Milky Way's veil. Future space telescopes, such as the James Webb Space Telescope and its successors, will provide deeper insights into these galaxies, allowing us to study their chemical compositions, star formation rates, and even their dark matter distributions. The next few decades could completely transform our understanding of the universe, as we finally begin to fill in the gaps in our cosmic map. But perhaps the most profound realization of all is the simple fact that we have been living in a universe far more mysterious and complex than we ever imagined. For centuries, we have looked up at the night sky and believed that we had a clear view of the cosmos. We thought that what we saw was a representative slice of reality. Now we know that entire galaxies, entire cosmic civilizations, perhaps, have been hiding in plain sight, waiting for us to develop the tools and the curiosity to uncover them. And if we have been wrong about something as fundamental as the number and location of galaxies in our own cosmic neighborhood, what else have we overlooked? What other secrets remain hidden, just beyond the reach of our instruments? The discovery of these galaxies is not the end of the story. It is the beginning of an entirely new chapter in our quest to understand the cosmos. And as we continue to push the boundaries of discovery, one thing is certain: the universe is not done surprising us yet. The realization that entire galaxies have been hiding behind the Milky Way's dense dust clouds is not just a minor adjustment to our cosmic map. It is a complete reconfiguration of how we perceive the universe. For centuries, astronomers assumed that our view of the sky was relatively complete, aside from minor obstructions caused by dust, gas, and interstellar debris. But now, with modern technology revealing a hidden world of previously unknown galactic structures, we are forced to confront the unsettling reality that our knowledge of the universe has been fundamentally incomplete. One of the most striking aspects of these newly discovered galaxies is the sheer diversity among them. Some are dwarf galaxies, barely visible even with the most advanced telescopes, their faint light drowned out by the intense glow of the Milky Way's core. Others are massive, sprawling structures that rival or even exceed our own galaxy in size and mass. These findings raise an important question. Why have these galaxies remained hidden for so long, and how have they managed to avoid detection despite their enormous scale? The answer lies in the nature of interstellar dust. The Milky Way is filled with vast clouds of microscopic dust particles, remnants of ancient supernovae, planetary collisions, and the gradual decay of cosmic material. These dust clouds absorb and scatter visible light, making it nearly impossible for traditional optical telescopes to see through them. This has resulted in what astronomers call the zone of avoidance, a region of the sky that has historically been almost impossible to study. But as we have developed infrared and radio telescopes, we have begun to penetrate this cosmic fog, revealing the galaxies that have been hidden behind it for billions of years. Infrared telescopes are particularly useful in this endeavor because infrared light can pass through dust more easily than visible light. By using infrared observations, astronomers have been able to detect the faint glow of hidden galaxies, mapping out their structure and composition in unprecedented detail. Meanwhile, radio telescopes have provided another way to peer through the dust, detecting the emissions of hydrogen gas, the fundamental building block of galaxies. These technologies have allowed scientists to piece together a picture of the galactic structures that were once completely invisible to us. What makes these discoveries even more fascinating is their potential to reshape our understanding of galactic evolution. The galaxies we can see in the observable universe follow certain patterns of formation and development, shaped by interactions with neighboring galaxies, the influence of dark matter, and the gravitational pull of the cosmic web. But what about the galaxies that have been hidden behind the Milky Way's dust? Have they followed the same evolutionary paths, or have they developed in entirely different ways due to their relative isolation from our known galactic structures? One possibility is that some of these hidden galaxies have existed in a kind of cosmic shadow, shielded from the gravitational interactions that have shaped more visible galaxies. This could mean that they have undergone less merging and disruption, potentially preserving ancient structures that could offer insights into the early universe. Alternatively, some of these galaxies may have experienced extreme gravitational interactions, hidden from our view until now, which could provide new clues about how galaxies collide and merge over cosmic timescales. Another intriguing question is whether these galaxies contain unique stellar populations. If they have been isolated from the larger galactic clusters that we have traditionally studied, their stars may have formed under different conditions, leading to unusual chemical compositions or even exotic types of stellar evolution. Some astronomers speculate that these galaxies could be home to an unusually high number of metal persists stars, which are among the oldest stars in the universe. Studying these stars could give us a window into the conditions of the early cosmos, potentially revealing new details about the formation of the first galaxies. The implications of these discoveries also extend to dark matter research. Dark matter is believed to make up roughly 85% of the total mass of the universe, yet it remains one of the most elusive mysteries in modern astrophysics. Scientists have long studied the motion of galaxies to infer the presence of dark matter, but if we have been missing entire galaxies hidden behind the Milky Way, then our calculations about dark matter distribution may need to be revised. These hidden galaxies could be key to solving the mystery of dark matter, providing new data points that help us understand how it shapes the universe. Beyond dark matter, these discoveries also have significant implications for cosmology. If our observations of the universe have been incomplete due to the zone of avoidance, then our models of cosmic expansion, galactic clustering, and the large-scale structure of the universe may need to be updated. The discovery of massive superclusters hidden behind the Milky Way suggests that our understanding of the cosmic web, the vast network of galaxies that form the structure of the universe, may be incomplete. We could be missing crucial connections between known galactic clusters, potentially altering our understanding of how galaxies are distributed across the cosmos. But perhaps the most exciting possibility is that these hidden galaxies could be home to planetary systems unlike anything we have ever encountered. The search for exoplanets has largely focused on the Milky Way, with astronomers detecting thousands of planets orbiting stars in our own galaxy. But if entire galaxies have remained hidden from us, then it stands to reason that countless exoplanets have also been concealed. Some of these planets may orbit stars in environments that are vastly different from those we are familiar with, potentially leading to the development of life in ways we have never imagined. Could civilizations exist in these hidden galaxies, completely isolated from the rest of the observable universe? If intelligent life has developed in these obscured regions of space, they may be completely unaware of the broader cosmic landscape. From their perspective, their entire universe could be confined to the galaxies visible within their region of space, much like how we once believed the Milky Way was the entire universe before the discovery of other galaxies. If advanced civilizations exist within these hidden galaxies, they may have been developing in total isolation, shielded from the influence of other potential civilizations by the vast clouds of cosmic dust that obscure their view. The ongoing search for these hidden galaxies is one of the most exciting frontiers in modern astronomy. With each new technological advancement, we gain a clearer picture of what lies beyond the Milky Way's dust clouds, revealing a universe that is far richer and more complex than we ever imagined. The discoveries being made today are not just filling in gaps in our knowledge, they are fundamentally altering our understanding of the cosmos, challenging long-held assumptions, and opening the door to entirely new possibilities. And yet, despite all of these breakthroughs, we are still only scratching the surface. If so many galaxies have remained hidden for so long, what else might we be missing? What other cosmic secrets lie just beyond our current ability to observe? The more we uncover, the more we realize how much remains unknown. The universe is not just vast, it is filled with mysteries that are waiting to be unraveled, and the hidden galaxies behind the Milky Way's dust are just the beginning. The discovery of hidden galaxies behind the Milky Way's dust is just the tip of the iceberg. With every new technological advancement, our understanding of these obscured cosmic structures continues to evolve. But the deeper we look, the more questions we face. If entire galaxies have been concealed by cosmic dust for billions of years, what else has escaped our detection? Could there be entire clusters, superclusters, or even structures beyond our comprehension lurking just out of sight? The very idea forces us to reconsider what we think we know about the observable universe. One of the most groundbreaking aspects of this revelation is that it challenges the concept of the cosmic horizon, the limit of what we can see due to the expansion of the universe. The universe is vast, stretching beyond our ability to observe it, but now we realize that even within our observable range, there are massive objects we've simply missed due to obstruction. This raises an unsettling thought. Our cosmic maps may be riddled with gaps, and our understanding of the large-scale structure of the universe might be far less complete than we assumed. To fully grasp the scale of what has been hidden, consider this. Scientists estimate that as much as 10 to 20% of the galaxies in the observable universe may reside in or near the zone of avoidance. That means that for every 10 galaxies we have studied, at least one has remained invisible to us. Some of these galaxies are small, faint, and difficult to detect, but others are enormous, rivaling or even surpassing the Milky Way in size and mass. What makes this discovery so shocking is that these aren't distant, unreachable galaxies at the edge of the universe. They are relatively close to us in cosmic terms, yet they have remained hidden in plain sight. The implications of this are staggering. If we have been missing entire galaxies within our immediate cosmic neighborhood, then our understanding of galaxy distribution is incomplete. The cosmic web, which is the vast interconnected network of galaxies that forms the large-scale structure of the universe, may have hidden connections and unseen gravitational influences that we have yet to account for. These hidden galaxies might be influencing the motion of other galaxies, affecting dark matter calculations, and even altering the way we understand the expansion of the universe itself. And then there's the question of dark matter. One of the biggest mysteries in astrophysics, dark matter is thought to make up most of the mass in the universe, yet it remains invisible to us. Scientists infer its presence through its gravitational effects on visible matter. But if our view of the cosmos has been incomplete due to these hidden galaxies, then our calculations regarding dark matter distribution may be off. It's possible that these hidden galaxies contain significant amounts of dark matter, potentially reshaping our understanding of how this elusive substance interacts with normal matter. Another critical aspect of these discoveries is how they could impact our understanding of galactic evolution. Galaxies do not exist in isolation. They interact, merge, and collide over billions of years, shaping their structure and star formation processes. If hidden galaxies have been isolated behind the Milky Way's dust, have they experienced a different evolutionary path than the galaxies we can easily observe? Are they relics of an ancient cosmic era, preserved in ways that more exposed galaxies are not? One theory suggests that some of these hidden galaxies might have formed under very different conditions than the galaxies we commonly study. They may have undergone fewer mergers, preserved more of their original gas, or developed unique stellar populations. Some astronomers suspect that these galaxies may contain an unusually high number of primordial stars, stars composed almost entirely of hydrogen and helium, with very few heavier elements. These stars, known as population 3 stars, are theorized to be the first stars that ever formed in the universe. While none have been directly observed yet, it is possible that hidden galaxies could harbor such ancient celestial bodies, providing a glimpse into the earliest epochs of cosmic history. The discovery of hidden galaxies also introduces a fascinating question: what kinds of planetary systems exist within these obscured regions of space? The search for exoplanets has so far been largely confined to the Milky Way, with astronomers using telescopes like Kepler, TESS, and JWST to detect planets orbiting stars within our own galaxy. But if entire galaxies have remained hidden behind dust clouds, then so have their planets. That means there could be trillions of planets that we have never even had the opportunity to detect. Some of these exoplanets may exist in conditions vastly different from anything we have observed before. Different types of stars, unique galactic environments, and varying levels of cosmic radiation could lead to planetary systems that challenge our existing models of planetary formation. And of course, the most tantalizing question of all, could any of these hidden planets harbor life? If intelligent life exists in these hidden galaxies, it raises profound implications for the search for extraterrestrial civilizations. Imagine a civilization developing in complete isolation, unaware of the broader universe beyond their galactic neighborhood. If their view of the cosmos has been similarly obstructed by dust, they might have reached the same conclusion that humanity did for much of its history, that their galaxy is the entire universe. They may have no knowledge of other galaxies, no awareness of cosmic expansion, and no reason to search for life beyond their hidden corner of space. This also raises questions about the Fermi paradox, which asks why, given the vast number of potentially habitable planets, we have yet to detect any signs of extraterrestrial life. If many advanced civilizations are located in obscured regions of space, their signals may simply not be reaching us. Or perhaps, like us, they are only now developing the technology to see beyond their own cosmic dust clouds. The discoveries being made today are just the beginning. As technology improves, astronomers will be able to map these hidden galaxies with greater precision, revealing details about their structures, star populations, and interactions. Future telescopes, such as the Nancy Grace Roman Space Telescope and more advanced radio observatories, will provide even deeper insights, allowing us to uncover even more of the universe that has been concealed from us. But what if even these new telescopes are still missing things? The hidden galaxies we have detected so far are only the ones that our current instruments can reveal. There could be even more obscured structures that require entirely new types of observational technology. Perhaps some galaxies exist in regions where dust is so dense that even infrared and radio waves struggle to penetrate. Could there be cosmic structures that are beyond our current ability to detect? As we continue to unravel these cosmic mysteries, one thing becomes clear: our understanding of the universe is still in its infancy. Every new discovery reminds us that we are only beginning to scratch the surface of what lies beyond our limited perspective. The universe is not just vast, it is teeming with hidden wonders, waiting to be uncovered. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.